So we'll be going through WAEC questions on periodic table and properties. So let's dive right in. Question 1. 2p and 3p orbitals have the same principal quantum number. The principal quantum number of an orbital is represented by the integers 1, 2, 3, 4, 5, and so on. Looking at that, we see that the principal quantum number here is 2 and the principal quantum number here is 3. So they do not have the same principal quantum numbers. How about energy level? So as the principal quantum number increases, so does the energy level. Although they have the same suborbital p, the energy level of 3p is higher than the energy level of 2p. So they do not have the same energy levels. Maximum number of electrons. So using the suborbitals, the suborbital S can carry a maximum of 2 electrons, P can carry a maximum of 6 electrons, D carries a maximum of 10, and F carries a maximum of 14. So they both have the same suborbital P, which means they will both carry the same 6 electrons in the orbitals. So they have the same maximum number of electrons. Then the shape. Each of the suborbitals have unique shapes. The s orbital, for instance, has a spherical shape. The p orbital has 2 lobes that look like a dumbbell, like this. So they both have the p suborbitals. This means they will both have the same shape, the dumbbell shape here. So they both have the same maximum number of electrons and they both have the same shape. That means the correct answer is B. So we'll go with B. Question 2. A transition metal would be expected to... So transition metals are elements that are found between group 2 and group 3 of the periodic table, and they have unique properties. So let's go through the options to see which of them corresponds to the unique properties of transition metals. A. Have an atomic structure with an incomplete outermost shell. Majority of the transition metals do have incomplete outermost shell, but there are exceptions to that rule. Zinc, for instance, is a transition metal, but it has completely filled outermost shell, so it does not apply to the option A, so A cannot be the answer. B. Have low density. Metals generally have high densities. So transition metals are also metals, and so they have high density and not low density. C. Have strong oxidizing ability. For an atom or element to have strong oxidizing ability, it means that it is a very good oxidizing agent. Oxidizing agents are agents that causes other atoms or molecules to become oxidized, but they themselves become reduced. And reduction happens by gaining electrons. So a strong oxidizing agent becomes reduced by gaining electron. But transition metals generally lose electrons to become stable. So they are not strong oxidizing agents, so they don't have strong oxidizing ability. Then D. Form oxide with different formulae. For this to happen, it means that the atom or the elements can form multiple oxidation numbers, such that when it combines with oxygen, we can have different formulas for the oxide. An example of that would be iron. Iron is a transition metal and it can form an oxidation state of +2 and also an oxidation state of +3. Okay, so if iron 2 forms a compound with oxygen, oxygen has the oxidation state of -2. So when the two of them combine, we'll have a compound Fe2O2. So what happened is that they just exchanged their valencies. The valency here is the 2 we see without the charge. So since the subscripts are the same thing, we just have a formula FeO. But if iron 3 combines with oxygen, oxygen has 2-. So again, they exchange their valencies. So So 2 here goes with iron and 3 goes with oxygen. So the formula becomes Fe2O3. So we can see that because iron has multiple oxidation states, it's able to form 2 types of oxide, this and this. And that's why the answer is D. So we'll go with D. Option D. Okay. An element Q forms a compound QCl5. In which group of the periodic table is Q? So in order to figure out what the group of Q is, we need to first find what the valency of Q is. And we can find that from the formula we have here, QCl5. So QCl5 means that the subscript 5 we see here is actually the valency for Q. And the subscript 1 that is here is the valency for chlorine. So Q has a valency of 5. Chlorine has a valency of 1. What this means is that for chlorine to become stable, it needs 1 electron. And so Q has 5 electrons in its outermost shell, which represents its valency. And so it will belong to group 5. So the correct answer is A. So we go with option A. Alright. An element whose atomic number is 19 has the electronic configuration. So we'd write out the electronic configuration in order of increasing energy level of the orbitals and then find which of the options correspond to the correct answer. So in writing out the electronic configuration of an atom, the increasing order of energy levels is 1s, 2s, 2p, 3s, 3p, 4s, 3d, and so on. Notice that 4s comes before 3d. That is because the energy level of 4s is lower than that of 3d. So when we're filling in the electrons, we make sure that the number of electrons we fill in do not exceed 19. So the s orbital carries a maximum of 2. This is also an s orbital, so 2. P orbital can carry a maximum of 6 electrons. The s orbital here will carry a maximum of 2. The p orbital here will carry a maximum of 6. Let's see how many electrons we have so far. 2 plus 2, 4, plus 6, 10, plus 2, 12, and then plus 6, 18. So 18 out of 19 means we have 1 more electron. So since this is already completely filled, the 1 electron will come into 4s orbital. So it means we do not need the 3d orbital because 4s is the highest orbital of this particular atom. So let's erase this. So the correct answer that corresponds to this configuration is option D. So we'll go with option D. Okay, an element with the electronic configuration of this would have a combining power of. So the combining power can be gotten from the number of valence electrons of an atom. And valence electrons refer to the total number of electrons in the outermost shell or the highest shell of that atom. So looking at this configuration, the highest shell here is shell 2. Because the highest integer we see is 2. So the highest shell is shell 2. So we'll combine the total number of electrons in the s and p orbital under shell 2. And that gives us a total of 2 plus 6, that's 8. So the total number of electrons in this atom, the outermost shell, is 8. So according to the octet rule, it tells us that the electron shell 2 needs 8 electrons to become stable. And once an atom becomes stable, it becomes unreactive because it has no reason to lose or gain electrons in order to combine with other atoms and then become stable. So an atom whose second shell or the outermost shell has 8 electrons would become unreactive, and that means the combining power is 0 because it would not combine with any other element or atom. So the correct answer here is D. Okay, an element X has an electronic configuration of this. So which group of the periodic table does X belong? So the group of an atom or an element refers to the total number of electrons in the highest shell or the total number of electrons in the outermost shell. So the outermost shell here, or the highest shell here, is shell 4. And the total number of electrons under shell 4 is 2. So which means the valence electrons of this element is 2, and that makes it belong to group 2. So the correct answer would be B. Alright, an element X with electronic configuration this combined with another element Y with this configuration, what is the formula of the compound formed? In order for us to write the formula of the compound, we need to first figure out what the oxidation number or combining power of each of the elements is. So for element X, the combining power or the valency of X can be gotten from the total number of electrons in the outermost shell. The outermost shell here is shell 3. So the total number of electrons under shell 3 is 2. Well, for Y, the highest shell we have here is shell 3. So the sum of all the electrons under shell 3 would be 2 plus 5, and that is 7. So in order for X to become stable, it has 2 electrons in its outermost shell. So for it to become stable, it needs to lose these 2 electrons so that the outermost shell becomes empty. So an atom becomes stable by either gaining a complete number of electrons in its outermost shell or losing the electrons to have an empty outermost shell. So it takes less energy to lose 2 electrons than for it to gain 6 electrons to become 8. So it's going to lose 2 electrons to become a +2 ion. When an atom loses electrons to become positively charged. While Y has 7 electrons in its outermost shell and it needs just 1 electron to complete 8. And so it would gain 1 electron and form a -1 ion. So to form a compound here, they exchange valencies here. So 1 goes with X and 2 goes with Y. So the compound formed become X1, Y2. And so we do not usually write the 1, so it becomes XY2. This means the correct answer is D. So go with option D. Alright, an element Y has the electronic configuration this. So what period does it belong in the periodic table? The period of an atom refers to the total number of electron shells it has. So we can get that from the configuration. We see what the highest shell is. So the highest shell is shell 3, which means that it has 3 electron shells. 3 electron shells means it belongs to period 3. The correct answer is B. Arrange the following elements in order of increasing electron affinity. Electron affinity here is the amount of energy that is released when an atom gains electron to form a negative ion. So we see that the molecules we have here are all halogens. This is bromine, chlorine, iodine, and fluorine. And halogens belong to group 7 of the periodic table. So for each of them to become stable or form molecules like these, they need to share 1 electron each. Okay, so since they all belong to the same group, we can tell the trend of the electron affinity by checking the trend of electron affinity down the period. So they all have different periods but the same group. Let's write out the different periods for each of the halogens we have here. So the first one is fluorine. Fluorine belongs to period 2 of the periodic table. Fluorine follows and belongs to period 3. Bromine belongs to period 4. And then iodine belongs to period 5. So as you go down the period, as the period increases in the periodic table, the reactivity of each of these elements also decreases. What that means is fluorine is more reactive because it tends to easily gain electron compared to chlorine. So fluorine would gain electron easily and release a large amount of energy called electron affinity. Chlorine has a larger electron affinity than bromine because chlorine is more reactive than bromine. Chlorine tends to gain more electron compared to bromine. So the trend continues downwards. So bromine has a higher electron affinity than iodine. So it means as the period increases going down, the electron affinity decreases. So in arranging these in order of increasing electron affinity, we start from the lowest and then to the highest, which means the first molecule is iodine, followed by bromine molecule, then chlorine molecule, and then fluorine. So the correct order here would be option D. Okay, so the correct option is D. Calcium and magnesium belong to the same group in the periodic table because they both K. So atoms that belong to the same group in the periodic table have the same number of electrons in their outermost shell. So atoms that belong to group 2 would have 2 electrons in their outermost shell. Group 3 would have 3 electrons in their outermost shell. And electrons in the outermost shell are also referred to as valence electrons. So the reason why calcium and magnesium belong to the same group is because they have the same number of valence electrons. So the correct answer is B. Question 11. Calcium and magnesium belong to the same group of the periodic table because they both... Okay, so the question is repeated. So atoms that belong to the same group have the same number of valence electrons, which means they have the same number of electrons in their outermost shell. Chlorine, bromine, and iodine belong to the same group, and so which of those options also describes chlorine, bromine, and iodine? Option A, react with alkaline metals. So all halogens, because these are halogens, all halogens react with alkaline metal. Alkaline metals are elements under group 1. So elements like sodium, lithium, potassium, and so on. So all halogens would react with elements in group 1 to form simple salts. So for instance, sodium can react with fluorine to give us sodium fluoride. Okay. Another example would be potassium reacting with chlorine to give us potassium chloride. So option A is correct. But let's go through the rest of the options to see. Form white precipitate. Now, not all of these three would form white precipitate. For instance, with silver nitrate, chlorine would form white precipitate. Bromine would form a creamy precipitate, and iodine will form a yellow precipitate. So B is not correct. C are all gaseous at room temperature. So chlorine is gaseous at room temperature, but bromine is a liquid at room temperature, and iodine is a solid at room temperature. So C is not correct. Then D reacts violently with hydrogen without heating. So chlorine and bromine are very reactive too, so they can react with hydrogen in room temperature without having to heat it. But iodine needs heat to be able to react with hydrogen. So iodine is the exception here, and that's why the answer is A. So we'll go with option A. Okay. Consider the following elements and their electronic configuration. So we have the configurations of elements W, X, Y, and Z. Which of the elements belong to the same group in the periodic table? So let's find out. The group refers to the total number of electrons in the highest or outermost shell of the element. Now for W, the highest shell for W is shell 2. And so we see that the total number of electrons under shell 2 is 2. So this means W belongs to group 2. Now for X has a total of 2 plus 6, 8 electrons under shell 2. So it belongs to group 8. Now for Y, the highest shell we have here is shell 3. And the total number there is 2. Yeah. Then for Z, the highest shell is also shell 3. But then the total number is 2 plus 2, and that is 4. So we see that the ones that belong to the same group are W and Y. So the correct answer is C. So we go with C. Okay. Consider the table. Which pair of elements are in the same group in the periodic table? Okay, so this is another way to write the electronic configuration. Okay, we can use the 288 method. So the last number you see here represents the number in the outermost shell of that element. So for J, it belongs to group 3 because 3 is the last number we see here, and that's the total number of electrons in its outermost shell. K belongs to group 2, L belongs to group 3, and M belongs to group 8. So the ones that belong to the same group would be J, and L. So J and L belong to group 3 of the periodic table. So the answer is C. Okay. Electropositivity of elements across the periodic table normally. So this is asking what the trend of electropositivity across the period is. As you move across the period, we're going from metals to non-metals. Electropositivity refers to the ability of an atom to lose electrons. Now, metals in group 1 to 3 would easily lose electrons compared to non-metals. Non-metals will rather gain electrons. So group 1 has the highest electropositivity because they have 1 electron in the outermost shell, so they would easily give out the 1 electrons compared to group 2. So as you're going from group 1 to group 8, the electropositivity decreases because the ability for the atoms to lose electrons starts to decrease. So across the period, electropositivity decreases. So the answer is B. Okay. Elements in the same group of the periodic table have, so groups of periodic table refer to the total number of electrons in the outermost shell, which are also called valence electrons. So it means that the correct answer would be D. They have the same number of valence electrons. So elements that belong to the same group in the periodic table are characterized by, okay, so let's see which one would correspond to elements that belong to the same group. Difference of 14 atomic mass units between the successive members, presence of the same number of electron shells in the respective atoms. So B refers to the period, not the group. Then presence of the same number of outermost electrons in the respective atoms. Then difference of +1 in the oxidation number of successive members. The correct answer is C because outermost electrons refer to the valence electrons, which then tells us the group of the elements. So elements which belong to the same group in the periodic table are characterized by, okay, so this is the same question. It means they are characterized by the presence of the same number of outermost electrons in their respective atoms, which means they have the same valence electrons. Elements with high ionization energies would, so what is ionization energy? Ionization energy refers to the amount of energy that is required to remove electrons from the outermost shell of an atom to form a positive ion. So a high ionization energy would mean that it requires very high energy to be able to knock out that electron. This is because the electron is tightly bound to the electron shell, and so it has a very strong attraction to the nucleus, so it would require a lot of energy to knock out that electron. So the option that closely describes one with a high ionization energy would be high effective nuclear charge, because when the nuclear charge is high, meaning the charge of the nucleus, if the charge of the nucleus is very high, which is positive, it has a very strong attraction to the electrons of that atom. So it would strongly attract the electrons and pull them closer to the nucleus, such that it requires a lot of energy to be able to overcome that attraction and knock off that electron in the outermost shell. So if an atom has a high effective nuclear charge, it would require a high ionization energy. So the answer is C. From the symbols below, which of the following ions have or has the configuration 2,8? Okay, so 2,8 tells us that the total number of electrons in this atom is 10. So 2,8, 2 plus 8 is 10. So which of these atom or which of these elements have atomic number of 10? Okay, so we see that none of these atoms have atomic number of 10. But then when they form ions, we can find out what their electronic configuration is. So for fluorine has an atomic number of 9, which means the configuration is 2,7. So 7 plus 2 is 9. Now, when fluorine forms an ion, it accepts one electron. When it accepts one electron, it becomes 2,8. Because accepting one electron would make the last shell 8, so it becomes a negative ion. Okay, so let's see for sodium. Atomic number of sodium is 11, and that is 2,8,1. So 2 plus 8 plus 1 is 11. So for sodium to become stable, it loses this one electron. So when it loses the one electron, it forms a positive ion. So that gives the configuration 2,8 because this one is gone then. Okay, so we have found 2. Magnesium has an atomic number of 12. So the configuration is 2,8,2. So 2 plus 8 plus 2 is 12. When magnesium forms an ion, it loses this 2 electron in the outermost shell to form 2 plus ion. So it becomes 2,8. So how about calcium? Calcium has an atomic number of 20. So the configuration is 2,8,8,2. So 2 plus 8 is 10 plus 8 is 18 plus 2 is 20. When calcium forms an ion, it loses this 2 electron in the outermost shell and becomes 2 plus. So the configuration becomes 2,8,8. Okay. So from these, we can see that the ions that have configuration 2,8 are fluorine, sodium, and magnesium. So the correct answer is 1, 2, and 3. And that is option A. So we go with option A. Alright. Given that the electronic configuration of an element X is this, it can be deduced that X, okay, so let's see, A belongs to period 4 in the periodic table. Now the period of an element can be deduced from the highest coefficient we have here. So the highest coefficient is 3 here, which means the highest shell is shell 3. So it belongs to period 3, meaning it has 3 electron shell and not 4. So A is not the answer. Belongs to group 6 in the periodic table. So the group is the total number of electrons in the highest shell or the outermost shell. So the outermost shell here is shell 3. And the total number of electrons under shell 3 is 2 plus 4. And that is 6. So it means B is correct. Does it have an atomic number of 27? When you add up all of the electrons we have here, it means the total number of electrons here is 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 4 is 16. So the atomic number is 16, not 27. So it contains 3 unpaired electrons in the ground state. So does it have 3 electrons in the ground state? We can find out by drawing the p orbital and fixing in the 4 electrons to see if how many unpaired electrons are there. So we can just quickly check that for future references. So the p orbital can have 3 sections this way. So now there are 4 electrons. So you fix in the electrons singly before you pair them. So we go in singly 1, 2, 3, and then the 4th one can come and pair with this 4. So it means that there are 2 unpaired electrons here. not 3 unpaired electrons. And that's why the correct answer is B. So it belongs to group 6 of the periodic table. The periodic property that is used to determine whether a covalent molecule is polar or not is, so a polar compound refers to a compound or a molecule that has partial positive and partial negative ends. What that looks like is, for instance, we can have water. So water is formed from 1 oxygen and 2 hydrogen atoms. So the hydrogen here has a partial positive sign. This is also partial positive, and then this is partial negative. This is because of the difference in electronegativities between oxygen and hydrogen. So electronegativity just refers to the ability of an atom to gain electron. Okay, so oxygen has a very high electron affinity because it has a high electronegativity, so it means that it is able to pull the electron to itself with greater force compared to hydrogen. So because oxygen pulls the electron closer, it will have a partial negative, while hydrogen does not have a strong pull on the electron, so it will have a partial positive sign. So the reason why we can have a polar or non-polar compound can be deduced from the difference in the electronegativity of the atoms. So the correct answer is B. So we'll go with B. Okay. Group 0 elements are unreactive because, so an atom becomes unreactive when it has complete number of electrons in the outermost shell. That way it doesn't need to lose or gain any electron to form a stable atom. So the reason why group 0 elements or group 8 elements are unreactive is because their highest occupied energy level is full. So the answer is C. Okay. Group 7 elements in their combined states are called, so group 7 elements are fluorine, chlorine, bromine, iodine, astatine, and they're usually called halogens as elements. But then when they combine with other elements, they are called halides. Okay, so the correct answer is halides, not halogens. Halogens are the elements themselves when they are not combined, but when they combine with other elements, that state is called a halide. So the correct answer is D. Helium is preferred to hydrogen in filling balloons because hydrogen, okay, so why is helium preferred to hydrogen in filling balloons? The reason is because hydrogen is inflammable. Okay, but helium is an unreactive gas. Helium is in group 0 of the periodic table, so it doesn't react with any other atom. So it doesn't combine with oxygen, it doesn't combine with any other atom. It's unreactive, so it's easy for helium to be used in filling balloons because we don't have any adverse effect to that. But hydrogen is a very reactive element, so if hydrogens are used in balloons in the air, it can combine with oxygen, it can combust with oxygen, and then we have water. So the reason why we don't use hydrogen is because it's inflammable. All right, so the answer is D. How many electrons are in the ion? Okay, so this is fluorine ion. The 19 up here represents the mass number, while the 9 down here represents the atomic number. So we can know how many electrons are there based on the atomic number of the ion. So let's write the atomic number of fluorine. Fluorine is number 9. So the configuration for chlorine would be, you can either say 2,7, okay, or you can use the SPD configuration, 1s2, 2s2, 2p5. So 2 plus 2 is 4, plus 5 is 9. Okay, so now this is a neutral fluorine atom, but we're asked how many electrons are in a fluorine ion. So fluorine forms a negative ion by accepting 1 electron to become stable. So it needs 1 electron to become a stable element. So it's going to accept 1 electron to become 2,8. So when chlorine accepts one electron, it forms a negative ion, and then you have 2, 8. Okay, so the total number of electrons in a fluorine ion is actually 10, because 2 plus 8 would give you 10. So the correct answer is C. Okay, so C. How many electrons are in the L shell of, this is phosphorus. So phosphorus is the 15th element. Now in this case, L is used to denote the parent electron shell. It is also, we can also use the integers 1, 2, 3, 4. So, but before 1, 2, 3, 4 was used, the letters K, L, M, N, O was used. So it means K corresponds to shell 1. So let's put that somewhere down. K means shell 1, L means shell 2, M means shell 3, and so on. So they're asking how many electrons are in the second shell of this atom, of this element. So let's write out the configuration for fluorine. It has 15 electrons. So 15 electrons would mean 2, 8, 5. So 2 plus 8 is 10, plus 5 is 15. We can also use the SPD configuration: 1s2, 2s2, 2p6, 3s2, then 3p3. So 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 3, 15. So in the third shell here, the total number of electrons is 2 plus 3, and that is 5. Okay, so now we're asked what the total number of electron is on the second shell. Sorry, not the third shell. So this is the second shell. The total number of electrons is 6 plus 2, and that is 8. So it has 8 electrons in the L shell, or in the second shell. So the correct answer is B. So go B. How many orbitals, I think that should be how many orbitals, are associated with the p sub energy level? Very good. So the p sub energy level has 3 orbitals, since it can carry a maximum of 6 electrons. So each orbital will carry 2 electrons. So it looks like this. So filling in the electrons singly and then pairing them. So we see that the p orbital can carry a maximum of 6 electrons, and each of the sub energy level can carry a maximum of 2 electrons. So it has 3 sub energy levels. So the correct answer is A. So we go with A. Alright, how many orbitals are in the d subshell? We just looked at the p subshell. Let's look at the d subshell. The d subshell can carry a maximum of 10 electrons, and each subshell carries 2 electrons spinning in opposite direction. So we have 1, 2, 3. Okay, so fixing in the electrons, we have electron 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the reason why D shell can carry a maximum of 10 electrons. So it has 1, 2, 1, 2, 3, 4, 5 subshells. The correct answer is C. So we go with C. Okay. How many principal electronic shells has an atom whose electronic configuration is shown below? Okay, so the principal electron shell is represented by the 1, 2, 3 we see here. So it means that it has 3 electron shell, because the highest coefficient we see here is 3. So the correct answer would be 3. So we can tell the principal shell of an element by the 1, 2, 3 we see there. So it has 3 electrons. Okay, how many unpaired electrons are present in ion 3? Okay, so let's write out the configuration for ion 3 and find out how many unpaired electrons are there. It would help to write the configuration for ion as a neutral atom first. So that's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d6. This should add up to 26. This is 4 plus 6, 10, 12, 18, 20, 26. So this is 26. Now for ion 3 plus, this means that ion has lost 3 electrons. So for transition metals, the electrons are lost from the 4s orbitals before the 3d orbitals, which means these 2 electrons are lost first, and then 1 electron from this is also lost. So the final configuration becomes 1s2, 2s2, 2p6, 3s2, 3p6, and 3d5. So this is the configuration for ion 3. So in order to find out how many unpaired electrons there are, we need to draw out the sub-energy level for orbital 3d. So the d orbital has 5 sub-energy levels. Okay, 1, 2, 3. Okay, so 5 sub-energy levels. There are 5 electrons here, so we go in singly before pairing. So 1, 2, 3, 4, and 5. So we stop there because it contains only 5 electrons. So each of those 5 electrons are not paired, meaning that the number of unpaired electrons are 1, 2, 3, 4, and 5. So the correct answer would be D. There are 5 unpaired electrons in ion 3. Alright, how many unpaired electrons are there in an atom of an element with the following electronic configuration? So we draw out the sub-energy level for the last orbital, which is 2p6. So the 2p6 orbital would look like this. The p orbital has 3 sub-energy levels, and there are 6 electrons here, so we go in singly, 1, 2, 3, then come back to pair them in the opposite direction, 4, 5, and 6. So we are fixed in the 6 electrons, and you notice that there are no unpaired electrons. All the electrons here are paired. So the answer is C, 0. There are 0 unpaired electrons in this configuration. So we go with C. If an atom of an element X is represented as this, which of the following deductions is or are correct? Okay, so let's find out. 1, X is chemically inactive. Is that true? We can know that by the electronic configuration of X. So we read the electronic configuration using the atomic number, and the atomic number here is the number down here, that is 2. So for an element with 2 electrons, the configuration would be 1s2 simply, and then we stop there. Now the first shell can carry a maximum of 2 electrons and become stable, and once it is stable it becomes chemically inactive or unreactive. So element X is actually unreactive because the first shell is stable and complete with 2 electrons. Now an atom of X has 2 neutrons. We can find out the number of neutrons from the mass number. The mass number is 4 here, and usually the mass number is the total number of protons and neutrons. So protons plus neutrons. So if we want to find the neutrons, we already know the mass number and the proton. The mass number is 4. Let's do little algebra. Equals the number of protons is the atomic number, which is 2. So 2 plus n. So subtracting 2 from both sides, or taking 2 to the other side of the equation, you have 4 minus 2 equals n. So 2 equals n, or n equals 2, which means there are 2 neutrons in this atom. So Roman figure 2 is also correct. An atom of X has only 1 shell. This is true because this is the only shell that atom X has. So 3 is correct. X belongs to period 1 of the periodic table. So the period is the total number of shells, electron shells it has. So it has only one electron shell, meaning that it belongs to period 1. So 4 is also correct. Means the correct option here will be 1, 2, 3, and 4. So we go with option C. Alright, question 34. If X is a group 3 element, its oxide will be represented as, so let's find out. If element X belongs to group 3, it means that it has 3 electrons in its outermost shell. And if it has 3 electrons in its outermost shell, it would lose these 3 electrons to form a +3 ion. When it combines with oxygen to form an oxide, oxygen has 6 electrons in its outermost shell. And so, having 6 electrons in its outermost shell, it needs 2 electrons to become completely 8. So it would accept 2 electrons and form a negative ion -2. So what we do here is we exchange the valencies of each of them. The valency referred to the combining power, the numbers here without the charge. So 2 goes to X and 3 goes to oxygen. So you have X2O3. So the correct answer is A. Okay. Alright, in the periodic table, alkaline earth metals can be found in group. Okay, so each of the group have a designated name. So group 1 elements are alkaline metals, while group 2 elements are alkaline earth metals. Okay, so it means that alkaline earth metals belong to group 2 of the periodic table. So the correct answer is C. In the periodic table, all the elements within the same group have the same. So elements in the same group have the same number of outermost electrons or the same valence electrons. The correct answer is C. So atoms in group 3 would have 3 electrons in the outermost shell or have 3 valence electrons. That is what this means. Okay. In which of the following atoms is the ionic radius larger than the atomic radius? Okay, so ionic radius refers to the radius of an ion, meaning the distance from the center of that ion to the last shell of that ion. So we have to write out the ions for each of these and then find out how the size of the ion differs from the actual neutral element. So let's start with sodium. Sodium is 11. Okay, so sodium, the configuration of sodium, we use the 2-8 configuration. So it's 2, 8, and 1. So when sodium forms an ion, it would lose 1 electron to form +1, and then the configuration becomes 2, 8, so it loses this 1 electron. For magnesium is 12, so the configuration is 2, 8, 2. Now when magnesium forms an ion, it loses this 2 electron on the outermost shell to form +2 or 2+, so the configuration becomes 2, 8. For aluminium is 13 with the configuration of 2, 8, 3. So when it forms an ion, it loses the 3 electrons in the outermost shell to form 2, 8. Okay, and +3. Now chlorine is 17. The configuration is 2, 8, 7. Now for chlorine to form an ion, it accepts 1 electron to complete 8 electrons in the outermost shell. So it looks like this. Configuration becomes 2, 8, 8. So how do you tell the size of the ion compared to the actual atom? For sodium, notice that there are 3 shells here, but then there are 2 shells here. So when the number of shells reduces, the radius will also reduce, because it means that the distance from the outermost shell to the nucleus has also reduced. So one with 3 shells would have a larger radius than the one with 2 shells. So the ion of sodium is smaller than its actual atom. Same goes for magnesium. This is 2 shells and then this is 3. So the radius here is smaller than the radius here because there are only 2 shells here. Same for aluminium. So generally for cations, positively charged ions, when they lose electrons, the shell reduces and so the radius also reduces. But for anions, when they accept electrons, they have more electrons than the actual neutral atom. Then what happens is that the added electron then repels the other electrons that are there because electrons are all negatively charged and like charges repel each other. So the more electrons you have in that shell, the more repulsion you get. And as they repel each other, it increases the size of the atomic shell or atomic orbital. So even though there are 3 electron shells here and there are 3 electron shells here, this would be larger than this because there is more repulsion of electrons here than there are here. So the size of this is larger than the size of this. So it means generally for anions, their ions have larger ionic radius than the actual neutral atom. So the correct answer here would be chlorine, and that is option B. So we go with option B. Okay. In which of the following series are atoms arranged in order of increasing ionization energy? So ionization energy refers to the energy required to remove electrons from the outermost shell of an atom to form a positive ion. So looking at the group of elements we have here, boron, beryllium, lithium, sodium, potassium. Okay, so let's see. Lithium, beryllium, and boron belong to the same period. So if they're in the same period, the trend we look at will now be the difference in their groups. Okay, so the question is, what is the trend of ionization energy when you have different groups? Okay, that means across the period. So as you're going across the period, the groups start to increase from 1 to 8. So lithium is in group 1, beryllium is in group 2, and boron is in group 3. As the group increases, the nuclear charge also increases. The number of protons in the nucleus also increases. This is because the atomic number increases. And as the nuclear charge increases, it has a very strong attraction to the electrons on the outermost shell. So it pulls the electrons closer to itself as the atomic number increases. So as you're going across the period, as the atomic number is increasing, so does the nuclear charge, and then you require more energy to pull out the electron in the outermost shell because of the stronger force of attraction it has to the nucleus. So it means that lithium would have a lesser ionization energy compared to beryllium and compared to boron. So as you're going from group 1 to 2 to 3, it means that the ionization energy would increase. Okay, so it means the correct answer here is A. So lithium is in group 1, okay, then beryllium is in group 2 and boron is in group 3. And as you increase in group, the nuclear charge also increases, and then the attraction with the electrons on the outermost shell increases. So you require more energy to pull out those electrons. So increasing order. Oh, the question was increasing order, so this is not the answer then, because this is decreasing order. If boron has a larger ionization energy, lithium has a lesser ionization energy, so this is decreasing order, so A is not the answer. Let's find out the other ones. So lithium, sodium, and potassium. Lithium, sodium, and potassium all belong to group 1, but they belong to different periods. So lithium belongs to period 2, sodium belongs to period 3, and potassium belongs to period 4. Okay, so as you're going down the period, the number of shells increases. Okay, so lithium has 2 shells, sodium has 3 shells, forgive this, and then potassium has 4 shells. Oh, I should have drawn that bigger. Wow. Okay, so what you notice here is that as the shells are increasing, the distance from the center of the nucleus to the end also increases, which means the force of attraction between the last shell and the innermost shell will also decrease. So the attraction from this to this is not as strong as the attraction from this to this. Neither is it as strong as the attraction from this to this. So this would require more ionization energy than this one. This would easily, the energy you need to knock out the electron from this one would be less than the energy you need here. So it means that if you arrange lithium, sodium, and potassium, the ionization energy decreases. Lithium would need more energy because the last shell of lithium is still closer to the nucleus compared to the rest. So lithium, sodium, potassium gives you an order of decreasing ionization energy. So the answer is not B either. So if you look at beryllium, magnesium, and calcium, so beryllium, magnesium, and calcium belong to the same group, right? Yes, they belong to the same group. They belong to group 2. But then they have different periods. And we just said that with different periods, as you're going down the group, as the number of electrons are increasing, the distance from the last shell to the middle shell to the nucleus increases, and so there is less attraction, which means the electrons in the outermost shell are loosely bound and can be easily knocked off. So as the period is increasing, okay, down the group, the ionization energy is decreasing. So beryllium is in period 2, magnesium is in period 3, calcium is in period 4. So as the period is increasing, the energy required to knock off the electron is decreasing. So this is a decreasing order of ionization energy. But then when we look at oxygen, fluorine, and neon, oxygen, fluorine, and neon all belong to the same period 2, but then they belong to different groups. So oxygen belongs to group 6, fluorine belongs to group 7, and neon belongs to group 8. So this is the group they belong also denotes the atomic number. And as the atomic number is increasing, so does the nuclear charge. Because oxygen has 6 protons in the nucleus, fluorine has 7 protons, and neon has 8 protons. So protons are positively charged. So in the nucleus, the charge in the nucleus is also increasing. And as the charge increases, there is a stronger attraction between the proton and the electron. So neon has a strong attraction between the nucleus and the electron. So it's very difficult to knock out the electron in neon. Fluorine also has a strong attraction, but compared to neon, fluorine requires a lesser ionization energy to knock off the electron in the outermost shell. Oxygen requires lesser energy compared to fluorine. So as the atomic number is increasing, so does the ionization energy, or the energy required to knock out the electron. So in increasing order, you have oxygen, fluorine, and neon. And that's why the correct answer is D. So we'll go with D. Alright. Ionization energy increases across the period in the periodic table because, so the reason why the ionization energy, which is the energy required to knock out the electron from the outermost shell, the reason why it increases across the period is because as you go across the period, the atomic number increases, and as the atomic number increases, so does the nuclear charge. The number of protons in the nucleus also increases. And as the nuclear charge increases, there's a stronger attraction between the nucleus and the outermost electron. So it takes a lot more energy to knock out the electron in the outermost shell if you have a high nuclear charge. The reason why the ionization energy increases across the period is because of the effective nuclear charge. Okay. Alright, so PQRS are metals in the same group in the periodic table, but in period 3, 4, and 5. 3, 4, 5, and 6. Okay, so let's write out what this means exactly. So it means that P belongs to, respectively, P belongs to period 3, Q belongs to period 4, R belongs to period 5, and S belongs to period 6. and the period means the number of electron shells it has. So this has 3 shells, okay, this has 4, this has 5, and this has 6. Now, which of them loses electron easily? Now remember that as the shell increases, okay, oh, let's do that again, that looks awful. Okay, let's clean this. Okay, so let's attempt that again. Let's draw 3 to 6 shells. So let's say this is the first shell. Oh wow, second, third, fourth, fifth. Okay, let's do 5 shells. We can still explain using 5 shells. Okay, so this is the nucleus. Okay, so which of them loses electron easily? Now, an electron that is here and an electron that is here experiences different attraction to the nucleus. The one that is on the second shell here has a stronger attraction to the nucleus compared to that on the 5th shell. So as the shells increases, the attraction of that electron to the nucleus decreases. So the hold that the nucleus has on this electron is not as strong as what it has on this electron or this electron or this electron. So this last electron can easily be knocked out compared to those that are closer to the nucleus. So it means that the electron that can be easily knocked off has to be the electron in the largest electron shell, and that is shell 6. So the electron in shell 6 can easily be knocked off because it is not so close to the nucleus, and therefore the force of attraction between that electron and the nucleus is not as strong. So the one that can easily lose electron would be S. So the correct answer is C. Okay, so we'll go with C. All right. Question 41. Pauli's exclusive principle is related to... So Pauli's exclusive principle is one of the principles that governs the combination of quantum numbers that is used to describe electrons in an atomic orbital. So what Pauli's exclusive principle states is that no 2 electrons in the same orbital will have the exact same values for their quantum numbers. Okay, so the reason why that is because for any atomic orbital, let's just do a visual representation of that. For any atomic orbital there are 2 electrons spinning in opposite directions. So even though those 2 electrons are contained in the exact same orbital, they are spinning in opposite directions. So the spin quantum number would be different. The one in the clockwise direction will have plus half, while that in the anti-clockwise direction would have minus half. So regardless of the fact that they both are in the same orbital, they cannot have the exact same quantum numbers. Okay, so the correct answer here is C. It's related to the quantum numbers of electrons. Okay, so the correct answer is C. Oh, B, sorry. B. Oh, wow. Okay, next question. Potassium and sodium show similar chemical properties because they... Alright, so when you're studying the periodic table, elements that have similar chemical properties are elements that belong to the same group. And belonging to the same group mean that they have the same number of electrons in their outermost shell, such that when they react, the valency or the number of electrons in their outermost shell is what determines how they react with other elements or atoms. So it means that the reason why they show similar chemical properties is because they belong to the same group of the periodic table. So 1 is correct. They have an equal number of electrons in the outermost shell. 2 is also correct, which means they have the same group. They both exist in +1 oxidation state in their compounds. Well, okay, is that true? Yes, because potassium and sodium are in group 1. And group 1 elements usually lose 1 electron. The 1 electron they have in their outermost shell, they lose that 1 electron to form a positive ion. And then the positive ion is +1, showing us that they lost 1 electron. So 3 is also correct. They belong to the same period in the periodic table. Okay, so no, they do not belong to the same period in the periodic table. Sodium belongs to period 3, while potassium belongs to period 4. What that means is that sodium has 3 shells, potassium has 4 shells. The correct answer is 1, 2, and 3. So C. Rare gases are stable because rare gases are also called noble gases or inert gases, and they are found in group 8 of the periodic table, or we also call them group 0 element. The reason why they're called group 0 elements is because they have completely filled outermost orbital, because the electrons in the outermost orbital have gotten to the maximum number. So they become unreactive because they do not need to lose or gain electrons to become stable, as they have already become stable. So the reason why rare gases are stable is simply because they have octet structure. That is the closest to the answer. Octet structure refers to a structure where you have 8 electrons in the outermost shell, and that makes it complete. So the correct answer is A. Okay. Sodium with an atomic number of 11 and cesium an atomic number of 55 are in group 1 of the periodic table. Which of the following statement is correct? Okay, so group 1 elements have 1 electron in the outermost shell, or 1 valence electron. So let's see, cesium combines with higher number of valence electrons. This is not true because they both have the same valence electron. So when sodium and cesium combine, they combine with 1 valence electron. B, sodium has a higher electronegativity value. So this would then relate to the trend of electronegativity down the group, which means when we have different periods, what happens to the electronegativity? According to the periodic trend, electronegativity, which is the ability of an atom to accept electron, increases across the period and decreases down the group. Now, sodium is in a lower period than cesium. Okay, cesium has a higher period than sodium, so it's down the period in the periodic table. And going down the period, the electronegativity value decreases, which means sodium has a higher electronegativity value than cesium. Okay. All right, so B could be correct. Let's look at C. Sodium has a lower ionization energy. This is not true because they are both in different periods, and cesium has a higher period than sodium, so it has a higher number of shells than sodium. And the higher the number of shells, the farther away the outermost electron is from the nucleus. So the attraction between the nucleus and the outermost shell is reduced. So it's easy to knock out that electron without requiring a very high ionization energy. So sodium will require a higher ionization energy than cesium because the last shell for sodium is still closer to the nucleus compared to that of cesium. So C is incorrect. D, cesium has a lower reducing ability. So the reducing ability of metals increases as you go down the period. As the period increases, the reducing ability increases because reducing ability depends on the ability of that atom to lose electron. And cesium loses electron more easily than sodium, so it has a higher reducing ability than sodium. Oh, reducing ability. Okay, reducing ability is the ability for it to reduce another atom, which means reducing agent needs to be oxidized, and so for atoms to be oxidized, they need to lose electrons. Okay, so the one that loses electrons more easily would have a stronger oxidizing ability. The one that loses electron easily would have a stronger reducing ability. So cesium loses electron more easily than sodium, so it has a stronger reducing ability than sodium. Okay, so that means the correct answer is B. I just have to double check there to make sure we are on the right track. Okay, so B is the correct option here. Okay, so moving on. The atom with the electronic configuration of this is in... Okay, so let's find out what's the period and what's the block for this atom. We can find the period by looking at the highest number of electron shells it has. So we can tell from the coefficients here that the highest number is 4, which means it has 4 electron shells, and so it belongs to period 4. So it belongs to period 4 of the periodic table. Now, but what block does it belong to? The block refers to the subshell, the highest subshell we have here in the 4th orbital. So the highest subshell where it stops is P. So it belongs to block P. So period 4, block P. So the answer is A. Okay, the atomic radii of metals are usually okay. So metals are those in group 1, 2, and 3. So we're trying to see what the relationship is between the ionic radius and the atomic radius of metals. Now metals lose electrons to form cations. So let's give a diagrammatic representation to better understand the relationship between the atomic radius and the ionic radius. Let's take lithium for example. So lithium has an atomic number of 3. So the configuration is 2, 1. Okay, so that means the first shell carries 2 electrons, the second shell carries only 1 electron. Now, but when lithium forms an ion, it loses this 1 electron, so it becomes +1, okay, and then the configuration becomes just 2, which means it only has 1 shell now with 2 electrons. Now, if you compare the radius of this, the radius is the distance from the center to the last shell here, and the radius from this, the center to the shell. The radius here is larger than the radius here, which means the ion of metals has lower radius or smaller radius compared to the actual atom. So the atoms have larger radius than the ions. So which of the option describes that? Option C, the atomic radius or the atomic radii of metals are greater than their ionic radii, which is true. The atomic radius of the metal here is larger or greater than its actual ionic radius. The correct answer here is C. So we go with C. Okay. The atoms of 4 elements are represented as this. Which of the elements will be unreactive? So an atom becomes unreactive when it has completely filled electrons in the outermost shell. So let's find out which of these have completely filled electrons in its outermost shell. So we do that by writing the configuration of each of them. So for Q has an atomic number of 20. So using the 2, 8 configuration, we can have 2, 8, and then 8, and then 2. So all of this would result to 20. Now if we write for R is 16, so that's 2, 8, and 6. Okay, then S has an atomic number of 10, which is 2, 8, and then T has an atomic number of 8, and that is 2, 6. So remember that for the atom to be stable, it needs to have 8 electrons according to the octet rule. So the only one that has 8 electrons in the outermost shell is this. So this is the one that is stable. It has 8 electrons, so it doesn't lose or gain any electron. So it becomes unreactive. The unreactive element here is S. So that tells us that the correct option here is A. So we go with A. Okay. The bonding pair of electrons in a hydrogen chloride molecule is pulled towards the chlorine atom because, so when you have a polar compound, okay, a polar compound is formed when the ends of the molecule are either positively charged or negatively charged. One end is positively charged and the other end is negatively charged. So if we have a hydrogen chloride molecule this way, this becomes partially positive and this becomes partially negative. The reason for this is because chlorine pulls the electron that is shared here. The line you see here represents a bonded electron, a pair of electron here. So chlorine pulls this pair of electron closer to itself than hydrogen. The reason for that is because chlorine has a very high electronegativity. So electronegativity describes the ability of an atom to gain electron to itself. So chlorine has a high electronegativity, and that is why it is able to pull this electron closer to itself compared to hydrogen. The reason why the pull towards chlorine is higher in this molecule is because chlorine is more electronegative than hydrogen. The correct answer is A. So we go with A. Alright. The compound formed by two elements X and Y with this electronic configuration respectively is. So let's find out what the combining power or the valency of each of the atom is. So starting with X, we can tell the combining power by looking at the valence electrons. Valence electrons refer to the number of electrons in the outermost shell. So the outermost shell here is 2. We're looking at the principal quantum number 2. The total number of electrons under shell 2 is 2 plus 4 for X, and 2 plus 4 will give us 6. So there are 6 electrons in the outermost shell of X. While Y, this is Y, not a funny looking X. Okay, so Y has the highest shell for Y is 3. So the total number of electrons in the third shell is just 2. Okay, so for X to become stable, for X to have an octet structure and have 8 electrons, it has to gain 2 more electrons to become 8. So in gaining 2 electrons, it forms a -2 ion. So the minus here represents gaining of electron. While for Y to become stable, instead of looking for 6 electrons, it would lose those 2 electrons, because losing 2 electrons takes lesser energy than gaining 6 electrons. And atoms usually go for the part that takes less energy. So it would lose 2 electrons to become +2. So in forming this compound, the combining power gets exchanged, right? Now, but here's the trick. This is an anion. This is a cation. In writing the chemical formula, the cation comes before the anion. So it means Y comes before X. So it means we're writing Y2, X2. And since the subscripts are the same thing, it means the compound is YX. So the answer is A, not B. The answer is not B because we write the cation before the anion. The correct answer would be A. Okay. So we go with A. Alright. The D block elements are paramagnetic because they. So paramagnetism describes the behavior of an atom in a magnetic field, and that is influenced by the number of unpaired electrons that atom has. So the higher the number of unpaired electrons, the higher its paramagnetism. Okay, so it means that, let's see, they are paramagnetic because they, let's see which of this, yeah, they contain unpaired electrons in the partially filled d orbitals. That's the correct answer. So paramagnetism is influenced by the unpaired electrons in an atom. So the correct answer would be B. Alright. The electronic configuration of ion 3 is, so let's find out what the configuration of ion 3 plus. Ion 3 plus means ion has lost 3 electrons. Okay, so would need to write out the electronic configuration of ion and then the electronic configuration of ion 3. Okay, so ion has a configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d. Now when ion forms a 3 plus ion, and ion, this happens when 2 electrons from the 4s orbitals are lost. So transition metals lose electrons from the 4s before the 3s orbitals. So 2 electrons here are lost, and then 1 electron from the 3d is also lost. So you have 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d5. So 2 plus 1 from here makes 3 electrons lost. So you have 3d5. Now notice that the configuration here uses the argon configuration as the prefix. So argon is element 18. It has 18 electrons. So let's count where does 18 stop. 2 plus 2 is 4, plus 6 is 10. Then this is 12, plus this 6 is 18. Okay, so it means that from this point to this point is argon. So if you put that as argon in a bracket, okay, and then remember we said the 4s orbital has lost its electron, so the 4s has 0 in it, and then we have 3d5. So this would be the configuration of ion 3, and that corresponds to option C. The correct answer is option C. Okay. All right. The electronic configuration of carbon atom in its excited state. Okay, let's draw out the sub shells for carbon and then figure out what the excited state would look like. Now, so carbon, the sixth element, has a configuration of 1s2, 2s2, and 2p2. 2 plus 2, 4, 5, 6. Okay, so our primary concern is the p orbital here. Now the p orbital has 3 sub energy levels, okay, and the sub energy levels are called xyz. So this is 2px, this is 2py, and this is 2pz. Now remember that there are 2 electrons here, okay, so 1, 2. So this is the neutral carbon atom. Now, but for it to become excited, let's draw this 2. This is 1s2, just to make it easier. This is 2s2. So the s has only 1 sub energy level. 2s2. This is the neutral atom for carbon. Now, excitation happens when an electron from a low energy orbital gains energy and jumps into a higher energy orbital. So when carbon atom gets into its excited state, the electron from the 2s here, one of the electrons here, gains energy and jumps from this lower energy and enters into a higher energy 2pz. So what it actually looks like is 1s2, 2s1, then 2px, 2py, and 2pz, each having 1, 1, and 1. So one electron from 2s jumps and then enters into the 2pz orbital. So instead of having this, you'd have 1 electron each in all the 2p orbitals. So that looks like this. Okay, so this is what the excited state looks like. Right, so what option does that correspond to? 1s2, 2s1. Yes, that's option D. So the correct answer is D. Okay. The electronic configuration, this is that of a, so we're trying to figure out what group this element belongs to. So we can tell by the total number of electrons it has on the highest shell or the outermost shell. So looking at this, we see that the outermost shell is shell 3. That's the highest shell we have here. So the total number of electrons in shell 3 is 2 plus 6. And that is 8. So there are 8 electrons in shell 3. And remember the octet rule. The 8 electrons means that the atom has become stable, and so it doesn't need to lose or gain electron. And stable atoms are usually called noble gases. They belong to group 0 or group 8. So the correct answer is A. The electronic configuration of an element is this. Where is the element located in the periodic table? Okay, so let's find out what the group and the period of this element is. We can tell what the group is by the total number of electrons it has in the highest shell or the outermost shell. The outermost shell here is shell 3. And the total number of electrons in shell 3 is 2 plus 3, that is 5. So it belongs to group 5. Now, the period tells us the total number of electron shells it has. So it has 3 electron shells because the highest number we see here is 3. So there are 3 electron shells here. And so it belongs to group 5 and period 3. And that is B. So the correct answer is B. Okay. The electronic configuration of an element X is this. It can be deduced that X, so let's see, belongs to group 6. Does it belong to group 6? The group is the total number of electrons it has in the outermost shell. The outermost shell here is shell 3. So shell 3 has a total number of 2 plus 4, 6. So it actually belongs to group 6 of the periodic table. Let's see the other ones, why they are wrong. It has 3 unpaired electrons. Now with 3p4, let's see if that is true. If you draw the orbital for 3p4, p has 3 sub-energy levels. Okay, so if you draw 4 electrons, you go in singly 1, 2, 3, and then you pair the 4th one here. So it means there are 2 unpaired electrons. So this is wrong, not 3 unpaired electrons. It belongs to period 4. Now the highest shell we see here is 3. So it belongs to period 3, not period 4. Then it has a relative molecular mass of 16. Well, the atomic number here is 2 plus 2, 4. 4 plus 6 is 10. Then plus 2, 12. Then plus 4. Oh wow. 12 plus 4, 16. Okay. So 16 here is the atomic number, not the molar mass, not the relative molecular mass. Relative molecular mass would give us the total number of protons and neutrons. But the information we're giving here only gives us the atomic number, which is the number of protons only. So D is not the correct answer. So the correct answer is A. So we'll go with A. The electronic configuration of 2 atoms X and Y are as follows. So this is X and this is Y. Which of the statements below is true of the position of X and Y? So let's find out what the group and period of X and Y is, and then we check the option for which is correct. So starting with X, we can tell the group of X by looking at the total number of electrons it has in its outermost shell or the highest shell. The highest shell here is 3, shell 3, and the electron in shell 3 is 1. So X belongs to group 1. Now the period tells us the total number of shells it has. So it has 1, 2, and 3 shells. Okay, so the highest number we see here is 3. That means it belongs to period 3. Now how about Y? The group for Y can be seen from the electrons it has in the highest shell here, which is the highest shell is 4, and the total number of electrons we have there are 2. So it belongs to group 2. Now the period tells us the total number of shells it has. The highest number of shells we see is 4 here, which means it belongs to period 4 because it has 4 electron shells. So which of the options corresponds to what we have here? So X belongs to group 1, Y belongs to group 2. I think that is the correct one. But let's see the others. X belongs to group 3, which is wrong already. X belongs to group 2, no. X belongs to group 1, Y belongs to period 4. X belongs to group 1, Y belongs to group period 4 is also correct. So, one says X belongs to group 1, Y belongs to period 2, which is wrong. Y belongs to period 4. Sorry. So it means the correct answer is D. X belongs to group 1, Y belongs to period 4. Okay. The correct answer is D. Okay. The electrons that are most easily removed from magnesium are in which orbital? Okay. So if we draw the atomic structure for magnesium, we can tell which electron would easily be removed from the orbital. So magnesium has an atomic number of 12, and that is 2, 8, 2. So if we draw the orbital, the first orbital takes 2 electrons. The second orbital That's a very funny looking orbital. 1, 2. Remember singly first before pairing. 3, 4. Oh, okay. Then 5, 6, 7. This already looks like 2, but let's just. So this is 8. Okay. Then the third shell. Oh boy. Has 2 electrons. Okay. So 1 and 2. Okay. So if we're using the SPD notation, this would be 1s2, 2s2, 2p6, and 3s2. So the 8 electrons we see in the second shell is 2 plus 6, 8 for the second shell. So the third shell, 3, has 2 electrons, which are these ones, this and this. So the electron that can be easily knocked out or removed from this orbital is the one in the last shell, because the attraction between the nucleus and this last electrons in the last shell is not as strong as those in the second shell. Those in the second shell are more strongly attracted to the nucleus than the last shell. So it will take lesser energy to remove the electrons from the third shell than it will for the second shell. So it means that the electrons that can be easily removed are found in the 3s orbital. So the correct answer is A. Okay. The element with electronic configuration this belongs to K. So we'll find out what the block, the period, and the group of this atom is. So first of all, if you want to know what the group is, you look at the subshell on the last atomic orbital. The subshell here is P. This is the last atomic orbital where the last electron is found, and that is P. So it belongs to P block. Now the period tells us the number of electron shells it has, which is denoted by 1, 2, 3, 4. So the highest number we see here is 3, which means it has 3 shells. So it belongs to period 3. Okay. Now the group can be found from the total number of electrons it has in the last shell. The last shell is shell 3. So the total number of electrons in this shell is 2 plus 1, and that is 3. So it belongs to group 3. So let's see. P block, period 3, group 3. That is option D. So the correct answer is D. The energy accompanies the addition of, okay, I think this should be the energy that accompanies the addition of an electron to an isolated gaseous atom is, okay, so the energy that accompanies the addition of an electron, meaning when an electron is gained by an atom, the energy that accompanies that is called the electron affinity. So when an atom gains electron, energy released is called the electron affinity. But when an atom loses electron, the energy required to do that is called the ionization energy. So that means the correct answer here would be electron affinity, which is D. The energy that accompanies the addition of an electron to a gaseous atom is called the electron affinity. Okay. Question 61. The energy change that accompanies the addition of an electron to an isolated gaseous atom is, so this is the electron affinity, the energy that is released when an atom gains electron. The energy required to remove the most loosely bound electron from an atom in the gaseous state is known as the, okay, so this is the ionization energy. That is the energy that is required to remove the loosely bound electron in the outermost shell of an atom to form a positive ion. The first definition of an element was made by Antoine Lavoisier, who defined an element as a substance that cannot be chemically broken down into simpler substances, basically. The following are S block elements except, okay, so you can know the block of an element by writing the configuration of that element to see where the last electron falls, what block the last electron falls. So let's do that. So magnesium has an atomic number of 12. So the configuration is 1s2, 2s2, 2p6, 3s2. This is 12. 4 plus 6, 10 plus 2, 12. So this is an S block element. How about aluminium? Aluminium is 13th element. So 1s2, 2s2, 2p6, 3s2, 3p1. So this is 10, 11, 12, 13. So this is the P block element. Okay, so I feel like we found our answer already, but let's just write the rest of them. 19 is 1s2, 2s2, 2p6, 3s2, is a 3, 3p6, 4s1. So all of this will give you 19. Yes, so this is an S block element. Then lastly, lithium. Lithium is the third element, so 1s2, 2s1. So 2 plus 1 is 3. So this is also S block. So the only odd one out here is aluminium, which is a P block element. So the correct answer is B. We'll go with B. The following ions have the same electron configuration, except, okay, let's find out what the configuration of the ions of these elements are. So first off, magnesium. Magnesium is a 12th element. So let's use the 2-8 configuration, 2-8-2. But when magnesium loses 2 electrons, it loses those 2 electrons, so it becomes 2-8 only. Now, aluminium, the 13th element, is 2-8-3. But when aluminium forms a 3+ ion, it loses those 3 electrons and becomes 2-8. Okay, oxygen is the 8th element. Okay, so that's 2,6. Now when oxygen forms a 2- ion, it gains, oh, this is 8, it gains 2 electrons to complete 8 electrons here. So it means the configuration is now 2-8. Then lastly, chlorine, which is the 17th element, you have 2, 8, and 7. Now when chlorine forms an ion, it gains 1 electron to make this last shell 8, so the ion becomes 2-8-8. So it means the answer is chlorine. The rest of them have 2-8 configurations except chlorine ion. So the correct answer is D. The following properties are characteristics of transition elements, except, okay, so transition elements have unique properties. They can act as catalysts. Okay, they can form colored compounds. Okay, so let's give examples of this. Acting as catalysts, we can have nickel. Nickel can be used as a catalyst for hydrogenation of hydrogenation processes that we use for making margarine. Okay, then formation of colored compounds. So compounds like ions like copper will form blue compounds. Okay, then ion 2 will form a green compound. Then we can have ion 3 forming brown. So they do have colors due to the partially filled d orbitals they have. Then they form complex ions. Of course, they do form complex ions. An example of a complex ion would be copper hexahydrate. Okay, so that's copper surrounded by 6 water molecules. Now, fixed oxidation state. This is wrong because they can have multiple oxidation states. An example is copper. Copper can be copper 1 plus and copper 2 plus. Iron can be iron 2 and iron 3, so they do have multiple oxidation states. So the correct answer is D. Alright, the following transition metal ions would be colored in aqueous solutions except the colored compounds we get from transition metals are due to the incompletely filled d orbitals of their ions. So if a transition metal does not have an incompletely filled d orbital, it would not give us a colored compound. So let's write out the configurations of these ions and see which one does not have an incompletely filled d orbital. So chromium is 1s2, 2s2, 2p6, 3s2, okay, then 3p6, 4s2, then 3d. The atomic number of chromium is 24. So 24 should be 3d4. Now, when chromium forms an ion, 2 plus ion, it loses those 2 electrons in the 4s orbital. So they lose electrons from the 4s orbital before the 3d orbital. So this goes away. Now 3d4, D can carry a maximum of 10 electrons, which means there are only 4 electrons here. So it means the D shell is not completely filled. So we would get a color for chromium. Now iron is 26. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. Okay, so when iron forms a +3 ion, it loses the 2 electrons here and 1 electron from 3d6. So 3d6 becomes 3d5. And 3d5 is also partially filled because the d orbital is not completely filled here. So we would get a color for iron 3. Now for manganese, so the oxidation number of the atomic number of manganese, let's see, that's 25. It's 25. So 2p6, 3s2, 3p6, 4s2, 3d5. Okay, so when manganese forms a +3 ion, it loses 2 electrons here and 1 electron from here. Then you have 3d4. So D block here is still partially filled. It's not completely filled. So we can get a colored ion here. Now for scandium, scandium is the 21st element. So the configuration looks like this: 2p6, 3s2, 3p6, 4s2, and 3d1. So this is 21. Now when scandium loses 3 electrons, it loses the 2 from 4s and loses the 1 from 3d. So there is no electron in the 3d orbital. And since there is no electron in the 3d orbital, it does not meet the criteria of a colored compound, because colored compounds are formed when the d orbital is partially filled, not empty and not completely filled, but partially filled. So because the d orbital is completely empty here, we won't get a colored compound here. That's why the answer is scandium. So scandium does not give a colored compound when it forms an ion. So the correct answer is D. So we go with D. The group to which elements belong in the periodic table is determined by the number of K. So what tells us the group of an atom or of an element is the number of electrons it has in the outermost shell. And those electrons are called valence electrons. So the answer is A. The ionic radii of metals are usually K. So what's the relationship between the ionic radii and the atomic radii of metals when they form ions? Let's find out. Okay, so we can use sodium as an example. Sodium as a neutral atom will give us 2, 8, 1. Okay, so 2 plus 8, 10 plus 1, 11. But when sodium forms an ion plus 1 ion, would have 2, 8 because it loses this 1. Now, it means that there are 3 shells here and there are 2 shells here. So for the 3 shells, we can have this for the sodium atom. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then the 11th one will be on the outermost shell here. Now, when it loses, this is for sodium atom. Okay, when it loses this 1 electron, this shell goes because it becomes empty. So we're left with only 2 shells. So let's draw that here. 1, 2, 3, 4, 5, 6, 7, and 8. This is sodium ion. Now the radius is the distance from the center here to the last shell. So the ionic radius here for the ion is distance from here to the last shell. You notice that the distance in the atom is larger or greater than the distance in the ion. So because it loses 1 electron shell, the distance from the center to the last shell reduces. So the ion has a smaller radius compared to the neutral atom. So which of the option agrees with that? So the ionic radius is lesser than the neutral atom. So that is B. Ionic radii is less than their atomic radii. So the correct answer is B. Okay, so we go with option B. The ionization energy is affected by the following factors except. Okay, so what affects the ionization energy of an atom? The ionization energy is the energy required to remove a loosely bound electron in the outermost shell of an atom to form a positive ion. So the factors that affect the removal of the electron in the outermost shell are the distance from the outermost electron from the nucleus. Okay, the distance of the outermost electron from the nucleus. This is true because the farther away the nucleus is, the farther away the electron is from the nucleus, the easily it is able to be knocked off, because the attraction between the nucleus and the outermost electron shell is not as strong as when it is closer to the nucleus. So the distance from the nucleus to the outermost shell is a factor for how large or small the ionization energy is. So A is a part of it. The ability to attract shared electrons. Ability to attract shared electrons refers to electronegativity, and that doesn't affect the ionization energy. Okay, because ionization energy is mostly related to ionic compounds, but shared pair of electrons refers to covalent compounds. So let's see the rest of them. The size of the positive nuclear charge. This affects ionization energy because if the nuclear charge, which is the charge in the center of the nucleus, that's the number of the protons, as the nuclear charge increases, the attraction between the nucleus and the outermost shell becomes stronger, and so it takes more energy to remove the electrons if the nuclear charge is higher. So C also affects the energy, and then D, the screening effect of the inner electrons. Screening effect refers to it's also called shielding effect. So let's draw an atomic orbital to see exactly what that means. If I have the first shell as this, and I have the second shell as this, let's just put in 4 electrons here. What screening effect means is that the 2 electrons in this shell are shielding these outer electrons from getting attracted to the nucleus. So it's like they are screening out this outer electron and making the attraction to the nucleus less. If I were to add another shell here, and I put an electron here, the inner electron here are called the core electrons. So the core electrons here are also shielding this last electron, from getting very attracted to the nucleus. So the shielding effect or the screening effect of the inner electrons affects how easily this electron can be knocked off. So the higher or the larger the screening effect, the less the energy required to knock off the electron, because it becomes easy to remove the electron since the attraction of the electron to the nucleus is less. So the correct answer is B. The ability to attract shared electron does not affect the ionization energy. So we'll go with B. So question 71. The maximum number of electrons that can be accommodated in a shell having the principal quantum number 3 is... So the formula for finding the maximum number of electrons when you're given the principal quantum number is 2n squared, where n is the principal quantum number. So which means in this case, n equals 3. So we have 2 times 3 squared. And 3 squared is 9, so 2 times 9, that is 18. So the correct answer is C. So we go with C. Okay. The metallic bond in magnesium is stronger than that in calcium because... So magnesium and calcium belong to the same group, meaning they have 2 electrons in their outermost shell. So the way in which they differ is the period. So magnesium belongs to period 3, which means it has 3 shells. So let's see, this is magnesium. Now calcium belongs to period 4, meaning it has 4 shells. So 1, 2, 3, and then 4. So the strength of a metallic bond is dependent on how strong of an attraction is between the center of the nucleus and the electrons in the outermost shell. So it means this is a measure of the atomic radius. The atomic radius is the distance from the center to the outermost shell. So the atomic radius of magnesium measures from the center to this point, while that of calcium measures from the center to this point. Now you'd notice that the atomic radius of magnesium is shorter or smaller than that of calcium, and so the attraction between the magnesium valence electrons and the nucleus is stronger than that between the valence electrons in calcium and the nucleus, because for calcium the valence electrons are farther away from the nucleus, so it doesn't have as much of an attraction as magnesium does. So magnesium will have a stronger metallic property because the atomic size of magnesium, or the atomic radius, is smaller, or the atomic size is smaller, whichever one is the correct answer. So it means that in this option the correct answer is A. Magnesium has a smaller atomic size, which means that the electrons in magnesium are more closely attracted to the nucleus than calcium. So the correct answer is A. The number of orbitals in a p sublevel of an atom is... So the p sublevel can carry 6 electrons and each sublevel carries 2 electrons. So for a p orbital, it will have 3 sublevels, such that you can have 6 electrons, 1, 2, 3, 4, 5, and 6. So this is the p orbital, which means it has p sublevels. Now carefully read the question in cases like this, because you could... it's easy to have an oversight here and think that the question is asking for how many electrons can go into the p orbital, and you think it's 6. So the electrons are 6, but the sublevel of the orbital is actually 3. So the correct answer is C. Okay, so we'll go with C. The periodic table is an arrangement of elements according to their... So the modern periodic law states that the elements in the periodic table are a periodic function of their atomic numbers. So which means the elements are arranged by their atomic numbers, not their atomic mass, not their mass number, but the atomic number. So the answer is D. The positivity of an element in the periodic table is determined by... So the positivity of an element refers to how easily it loses electrons. Now, the number of protons in an atom refers to the nuclear charge or the atomic number. So as the nuclear charge or the atomic number increases, the attraction between the center of the atom and the valence electrons is stronger. So it's not so easy to remove the electrons in the outermost shell. So as nuclear charge increases or as atomic number increases, the positivity of an atom decreases because it doesn't easily or readily lose its valence electron. So what affects the positivity of an atom is the number of protons in its atom. So A. Alright, 76. The presence of unpaired electrons in an atom of a D element accounts for is. So the correct answer here is paramagnetism. Paramagnetism is influenced by the number of unpaired electrons in a D block element, because the higher the number of unpaired electrons, the higher the paramagnetism. And paramagnetism describes the behavior of an atom in the presence of a magnetic field. So an atom with a very high paramagnetic property will become more attracted to the direction of the applied magnetic field, while those with weaker or lesser unpaired electrons, we have a weak attraction to the direction of the applied magnetic field. So the answer is B. The presence of unpaired electron in an atom of a transition metal gives rise to. So the correct answer is paramagnetism, because paramagnetism is influenced by unpaired electrons, and it describes the attraction of an atom to the direction of an applied magnetic field. The property of elements which increases down a group of the periodic table is. So which of these increases down a group? Now, electron affinity, which is the energy released when an atom gains an electron, increases across the period and decreases down the group. Electron negativity, which describes the ability of an atom to attract electron to itself, increases across the period and decreases down the group. Ionization energy, which is the energy required to remove the loosely bound electron in the outermost shell of an atom, increases across the period and decreases down the group. So the ionic radius, which is the distance from the center of an ion to the last shell, also takes the same trade of atomic radius, and it decreases across the period and increases down the group. So the correct answer is D. The reactivity of fluorine is high because, so fluorine reacts very readily because it is very highly electronegative. This means that it easily accepts electron to itself. So that describes its high electronegativity, and that's why it is a very reactive element. So the correct answer is C. The reason for the decrease in the atomic size of elements across a period is that, so why does atomic size decrease across a period? The reason is because the nuclear charge as you go across the period increases, and as the nuclear charge increases, there's a strong attraction between the nucleus and the outermost electron, and so the outermost electrons are pulled closer to the nucleus, thereby decreasing the size of the atom and thereby decreasing the atomic radius of that atom. So the correct answer is because the nuclear charge increases while the outermost electrons are drawn closer to the nucleus, and that is A. Alright, question 81. The species with no electron in the 3D orbital is. So we need to write out the configuration for all of these and find out which one has no electron in the 3D orbital. Okay, so zinc 2+. Now zinc is the 30th element. It has an atomic number of 30, and the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d10. So all of this will give you 30. Now when zinc forms the 2+ ions, it loses 2 electrons, and the 2 electrons come out of 4s orbital. So it loses electron from the 4s before the 3d. So the 4s orbital is gone, and then it has electrons in the 3d orbital, so it's not zinc. Now copper here is a neutral atom, not an ion, so we'll write the configuration for copper as a neutral atom. And copper is the 29th element, so that's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d now. So ideally this should be the configuration for copper, but then for the sake of stability, atoms will usually have electrons either be half filled or completely filled. So instead, the correct configuration for copper is actually 4s1 and 3d10. So the s shell that carries 2 orbital will be half filled because 1 is half of 2, and then the d orbital that carries 10 will be completely filled. So this is a more stable configuration for copper. Now, but we can see that there are electrons in the 3d orbitals of copper, so it means copper is not the answer. For scandium, scandium is the 21st element, so we have 1s2, 2s2, 2p6, this is 6, 3s2, 3p6, 4s2, and 3d1. So this is the configuration for scandium as a neutral atom. But when scandium forms the 3+ ion, it loses 3 electrons. So 2 electrons come out of 4s and the third electron comes out of 3d. So it means that it does not have a 3d orbital. It stops at 3p6. So the correct answer is scandium. Scandium 3+ has no electron in the 3d orbital. So we'll go with option C. The two elements X and Y are in the same group because they have the same elements in the same group are classified that way because they have the same number of electrons in their outermost shell, and those electrons are called valence electrons. So the answer is A. The valence electron of the element magnesium are in the, so which of the orbital do the last electrons in magnesium fall? So let's write out the configuration for magnesium to find out what the last block of magnesium is. So magnesium is the 12th element. Okay, so atomic number is 12. The configuration is 1s2, 2s2, 2p6, and then 3s2. So this is 12 electron. So it means that the valence electron of magnesium fall under the 3s orbital. So the correct answer is B. So we'll go with B. The valence electron of magnesium are in the, okay, so we write out the configuration for magnesium here. So with an atomic number of 12, the configuration is 1s2, 2s2, 2p6, and 3s2. So the valence electrons of magnesium are in the 3s orbital, the last orbital here. So the answer is D. So we'll go with D. Alright. So which group and period respectively does an element with 15 electrons belong? Okay, so we'll write out the configuration for an element with 15 electrons. So 15 electrons in order of increasing energy level: 1s2, 2s2, 2p6, this is letter P, 3s2, 3p, let's see, 16. This is 6 plus 4, 10, 12. So we're left with 3 electrons, so 3p3. So this is the configuration for an element with 15 electrons. Now, the group of this element is found from the total number of electrons in the outermost shell. The outermost shell here is shell 3. So we sum the electrons here. 2 plus 3 is 5. So it means it belongs to group 5. Now the period tells us the total number of electron shells it has. So the electron shells are represented by the numbers we see here. So the highest number here is 3. So it means that this atom has 3 electron shells, which means it belongs to period 3. So group 5, period 3. So what does that? Respectively, group and period. So we need group 5, period 3. So the answer is A. Okay. Two elements X and Y combine to form a compound with formula X2Y3. Which of the following representations would fit the configuration of X and Y? Okay, so let's figure out what the combining power of X and Y is, and then we can figure out what configuration matches that. So if it forms a compound X2Y3, this way, X2Y3, so the combining power of X is 3 and that of Y is 2 because they exchange combining powers when forming a compound. So it means X combines with 3, Y combines with 2. Now the cation is written before the anion. So the cation, which is the positive ion, is X, which means this is plus 3. The anion is Y, which is minus 2. Okay, so what this means is that X loses 3 electrons. So it has 3 electrons in the outermost shell. So for it to have 3 electrons in the outermost shell, when you're writing the configuration, it has to end with a 3. So possibly 2, 8, and 3. So that it loses these 3 electrons to form a compound. Now Y has an oxidation number of minus 2. What this means is that Y gained 2 electrons. So for Y to gain 2 electrons and complete 8 electrons, it needs to have 6 electrons in its outermost shell. Okay, so it could be 2, 6, such that it gains 2 electrons to become complete here. So the configurations that will match X and Y are 2, 8, 3 and then 2, 6. So the correct answer is B. Okay. Two elements X and Y are in the same group on the periodic table because they both have the same. So elements in the same group of a periodic table contain the same number of valence electrons, which is the same number of electrons in their outermost shell. Use the following information to answer this question. A metal X forms 2 chloride with the formula XlCl2 and XCl3. Where is X in the periodic table? Okay, so let's find out. So XCl2 and XCl3. Now chlorine here will always have a combining power of 1, but we see that X can have a combining power of 2 and 3. So plus 2 and plus 3, since that is the cation. What this means is that X has multiple oxidation states, and this characteristic of having multiple oxidation states is unique to transition metals, and transition metals are also called D block elements. So the correct answer is B. It is a D block element because it has multiple oxidation numbers, which is unique to transition metals. So the correct answer is B. What is the atomic number of an element whose cation Y plus has an electronic configuration of this? Okay, so this is the configuration of the ion, but we need to know what the atomic number is as a neutral atom. So Y plus 1 means that it lost 1 electron, which means that this configuration should have, for it to be complete as a neutral atom, it needs to have 1 more electron. So the electrons we have here are 2 plus 2, 4, plus 6, 10 for this ion. But seeing that it lost 1 electron, the actual atomic number would be 11. So 11 losing 1 makes it become 10. So the actual atomic number is 11 and not 10. Okay. What is the electronic configuration of an element represented as this? So we write electronic configurations using the atomic number of the element, and the atomic number is the one written as a subscript here, which is 9. So let's write the configuration for an atom with 9 electrons. So in order of increasing energy level, we have 1s2, 2s2, 2p6. Oh, 9, right? So this is 6, 7, 8, 9, 10. That's beyond 9. So let's adjust to that. Okay. So 2 plus 2, 4. So we're left with 5 electron. So this would give us 9. So the configuration is 1s2, 2s2, 2p5. And that is option B. What is the most probable group of an element? A soft silvery white solid that reacts violently with water. So the group of elements that react violently with water to produce an alkaline solution are the group 1 element. Furthermore, they are also solid at room temperature. They have metallic luster, meaning that they have shiny surfaces. So that explains the silvery property of the element, and then it is also soft. So the best group for this is group 1. Which elements have a ground state electronic configuration with an incomplete penultimate shell? So the penultimate shell of an atom, one element, is the second to the last shell, the shell before the valence electron. So if the valence electron is the outermost shell, the shell with the outermost electrons, then the penultimate shell is the shell before the valence shell. So we'll write out the configurations of these elements and see which one has an incomplete penultimate shell. So starting with sodium, sodium has an atomic number of 11. So the configuration would be 1s2, 2s2, 2p6, and 3s1. The penultimate shell here will be 2p before 3s, which is complete because it has 6 electrons in its outermost shell. Now, calcium with 20 electrons, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay, so 4s2 is the valence shell, while this is the penultimate shell, which is also complete because it's carrying 6 electrons. Now for aluminium, 13, 1s2, 2s2, 2p6, 3s2, 3p1. So these are 13 electrons. So the valence shell is this, then the penultimate shell is this, which is complete because it's carrying 2 electrons. Now for iron, number 26, so 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2. For the sake of this question, I've put 3d before 4s, but 4s has a lower energy than 3d orbital. But when they lose electrons to form ions, they lose electrons from the 4s orbital before the 3d. So technically the 4s orbital would represent the valence orbital, while the 3d will represent the penultimate orbital. Okay, so since they lose electrons from the 4s first, these will become the penultimate, and this is incomplete because the d shell carries 10 electrons. So this is 6, meaning that is incomplete. The correct answer would be iron. So we'll go with iron. This question has been flagged, so we'll skip it because the options do not correspond to the actual question. Let's go to the next question. Which of the electrons in the following orbitals would experience the greatest nuclear attraction? Okay, so let's eliminate those that are not the answers. So the 1s orbital is closest to the nucleus than the 2s orbital. So we can eliminate the 2s orbitals B and D. So 1s orbital of potassium and 1s orbital of helium. The 1s orbital of helium is very close to the nucleus because helium is in period 1, so it only has 1 orbital, while potassium has 3 orbitals. Now, although we're referring to the 1s orbital, which is the first orbital, that of helium would experience more nuclear attraction because it only has one shell. And so all of the attraction from the nucleus is focused on the one shell. While for potassium, it has 3 shells, so it attracts the first, second, and third shell. So the first shell may not experience as much attraction as the first shell of helium. So the answer is C. Which of the electrons in the following orbitals will experience the greatest number of attraction? So the 1s orbital are closer to the electron than to the nucleus than the 2s orbital. So either the 1s orbital of helium or that of potassium. Now that of helium would experience more nuclear attraction because helium has only one shell, which is the 1s shell. So the attraction between the nucleus and helium is stronger than in potassium that has 3 shells. So although we're referring to the 1s shell, the 1s shell of helium has more attraction than potassium. The answer is A. So study the table and use it to answer the question. Okay, so which of the elements in the table above can be classified as a metal? So melting point. Now metals generally have high melting points. Okay, so metal element 2 looks like the answer because it has high melting points. But then let's consider the other ones. Now, physical state of these oxides. The oxides of metal are solids. They're crystalline solids at room temperature. So that actually eliminates 2. So 1 and 3 could be the answer. Now let's consider the third one. Very good conductor of electricity. Nil means it doesn't conduct electricity, and then this is also a good conductor of electricity. Now metals are generally good conductors of electricity, which confirms that 1 and 3 could be the answer. So the question we might want to ask is, how is it that 1 is the answer when it has a very low melting point? Now, an exception to that rule is mercury. Mercury is a metal, but then it has a low melting point. But then the oxide of mercury is a solid at room temperature. So that explains why we have a minus 39 here, because this is actually referring to mercury. Now, the melting point of 2 is very high, but why is it that that's not the answer? Or why is it that that's not a metal? So first of all, we just said that it doesn't conduct electricity and the oxide is gaseous, which is a quality of non-metal. So the exception to the rule of a high melting point is bromine. Bromine has a high melting point, although it's a non-metal. So that explains the figure we see here. So the correct answer would be 1 and 3, which means that's option D. Which of the following arrangements indicate the correct decreasing order of ionization energies of period 3 elements? So all of these are period 3 elements, okay? But they all belong to different groups of the periodic table. So as you're moving along the period where you have different groups, the ionization energy increases. It increases because moving across means the atomic number is also increasing. An increase in atomic number results in increase in nuclear charge. Nuclear charge refers to the charge of the nucleus. The protons are in the nucleus. So the atomic number tells us the number of protons. So as the number of protons are increasing, the charge of the nucleus is also increasing. And if the charge of the nucleus is increasing, there's a stronger attraction between the nucleus and the outermost electron. So it takes more energy to knock out that electron because it experiences more attraction to the nucleus. So moving across the period where groups increases, then the ionization energy increases. So if we are to arrange this in order of decreasing order of ionization energy, it means we have to start from the one that would experience the highest ionization energy, and that would be the one with the highest group. So arranging them from the highest group to the lowest would give us chlorine, phosphorus, aluminum, and sodium. Chlorine is in group 7, phosphorus is in group 5, aluminum is in group 3, and sodium is in group 1, so the answer is B. Which of the following arrangement is in decreasing order of atomic radius? Okay, so we have carbon, beryllium, boron, and lithium. All of these belong to the same group but different periods. So we're looking at the trend as the period increases, down the group. So the atomic radius going down the group as periods increase would also increase because the number of shells are also increasing. And as the number of shells increases, the last shell is farther away from the nucleus. And the atomic radius measures the distance from the nucleus to the outermost shell. So as we keep increasing the period and increasing the number of shells, that increases the distance between the nucleus and the outermost shell. So it means that as the ones with the higher period will have a larger atomic radius. So if we arrange this in decreasing order of atomic radius, it means we are going from the highest to the lowest. So the elements with the highest atomic radius would be the one in the highest period. So the one in the highest period, my bad. They all belong to the same period, sorry, but in different group. So they all belong to period 2. Lithium, beryllium, yes, they all belong to period 2. So what is the trend of atomic radius across the period where the groups are different? So all of these belong to different groups. And as you move across the period, the nuclear charge increases because the number of protons increases. And number of protons are found inside the nucleus. So if protons increases, the charge of the nucleus increases. And this increases the force of attraction between the nucleus and the outermost shell. So this pulls the electrons from the outermost shell closer to the nucleus and reduces the distance between the nucleus and the outermost shell. Therefore, it reduces the atomic radius of that atom. So as the group increases across the period, the atomic radius decreases. So in order of decreasing atomic radius, we'll start from the one with the lowest group and then move from there. So the one with the lowest group is lithium, then followed by beryllium, then boron, and carbon. So the answer is D. Which of the following arrangements is in order of increasing ionization energy? Now, all of these elements belong to the same period but different groups. So what is the trend of ionization energy as the groups changes across the period? So across the period, ionization energy increases because the nuclear charge, which is also the number of protons in the nucleus, increases as the atomic number increases. An increase in nuclear charge causes the electrons in the outermost shell to be very attracted to the nucleus. And as they're attracted to the nucleus, they are pulled closer to the nucleus, reducing the size of that atom. And as the size of the atom reduces, the radius also reduces. And it takes a lot of energy to pull out the outermost electron. So as you're going across the period, you need more energy to pull out the electrons from the outermost shell. So if we're to arrange this in order of increasing ionization energy, we go from the lowest group to the highest group. So the lowest group to the highest group would be aluminum, silicon, phosphorus, and sulfur. So sulfur has a higher ionization energy than aluminum because the attraction between the nucleus and the outermost shell of sulfur is stronger than that of aluminum. So the answer is B. Which of the following arrangements is in order of increasing metallic property? So the metallic property of metals in the periodic table, let's see if they have the same period or the same group. So they're in the same group, they're all in group 1. So the trend of metallic property as you're going down the group is that the metallic property decreases. So the metallic property decreases because metallic property is dependent on the attraction between the electrons in the outermost shell and the nucleus of the shell. So as the shell increases, the attraction between the outermost shell and the nucleus decreases, which means as the period increases, as you keep adding more electron shell, there's a longer distance between the outermost shell and the nucleus, and so the metallic property will decrease. So as you're going down the group where period increases, metallic property decreases. So in order of increasing metallic property, we'll start from the lowest to the highest. So the lowest here is potassium, followed by sodium, then lithium. So lithium has a higher metallic property than potassium. So the answer is B. So which of the following arrangements of elements is in decreasing order of electronegativity? If you study the elements that are here, you notice that the elements here belong to the same period, but they have different groups. So what is the trend of electronegativity as you're going across the period where the groups are changing? So across the period, electronegativity increases. So electronegativity describes the ability of an atom to gain electron. So as you're going across the period from metals to non-metals, non-metals tend to gain electron easily than metals. So across the period, electronegativity increases. So if we arrange this in order of decreasing electronegativity, we'll start from the one with the highest electronegativity, which would be the most the non-metal down to the metal. So that order will be phosphorus, silicon, aluminum, magnesium, and sodium. So sodium is a strong metal, which means it will rather donate electron than accept electron, which means sodium has a high electropositivity but low electronegativity. So the answer is A. Which of the following arrangement represents the correct order of electronic energy levels? Okay, so it's 1s, 2s, 2p, 3s, 3p, 4s, then 3d. So 4s has a lower energy than 3d, so it comes before 3d. So the correct answer would be A. Which of the following arrangements shows increasing order of reactivity of halogens? So halogens are elements in group 7 of the periodic table, and the reactivity of halogens decreases as you go down the group, down the period, sorry. So it means from fluorine down to astatine or iodine, the reactivity starts to decrease. So fluorine is the most reactive halogen, while iodine or astatine is the least reactive. So since the highest halogen we see here is iodine, so it means that fluorine is most reactive, iodine is least reactive. So in increasing order of reactivity from the lowest to the highest, it means to start from iodine, followed by bromine, then chlorine, then fluorine. Okay, so the correct answer is B and C. Okay, so looking at the sign greater than and less than, this is a bit tricky. Okay, so iodine is greater than bromine, greater than chlorine, greater than fluorine. This is wrong. It should be iodine is less than bromine, then less than chlorine, then less than fluorine. So the answer is C. Which of the following cannot be deduced from the electronic configuration of transition metal? So the configuration of transition metals can tell us some of the properties of the transition metals. So its ability to form complex ion is actually not, you can't tell that from configuration of transition metal, but you can tell the position from the configuration. You can tell the magnetic property by the number of unpaired electrons it has, and then you can also tell the variable oxidation states by the electronic configuration. So the property we cannot tell from the configuration is its ability to form complex ions. The next question. Which of the following decreases from left to right across the period but increases down the group in the periodic table? Okay. So which one decreases from left to right and increases as you're going down? Now, ionization energy increases from left to right but decreases down the group. So it's not ionization energy. Electron affinity increases across the period but decreases down the group. Electronegativity increases across the period and decreases down the group. Now, atomic radius decreases across the period but increases down the group. So the answer is 4 only. Which of the following electronic configuration correctly represents an inert element? An inert element refers to an element that is unreactive. And an unreactive element is an element or atom that has completely filled outermost shell or orbital. So if you look at the configuration here, the last orbital here is the third one and it has 2 electrons. So the third orbital can carry a maximum of 8 electrons. So you have an s and a p orbital. So the p orbital would carry 6 plus the 2 extra would give us 8. So the third orbital here is incomplete. So we are paying attention to the primary orbital here, not the subshells, not the SPD, but the 1, 2, 3. So the third shell can actually carry 18 electrons. So this is not complete. So this is not an inert gas or an inert element. Now looking at this 1s2, 2s2, 2p4, this is also not complete because in the second shell 4 plus 2 is 6 and we need to have 8. Now in the third one, the second shell has 6 plus 2, 8. So second shell is complete. Now why is D not the answer? Because D, the third shell, carries only 6 electrons instead of 18 electrons. So the answer is C, where it has 8 electrons in the second shell. Which of the following electron configuration represent that of an atom in its ground state? Okay, ground state means its neutral state, where it has not formed an ion. It did not lose or gain any electron. And the ground state also means that the atomic number is the number of protons, which is equal to the number of electrons. Okay, so which configuration represents an atom in its ground state? So 1s2, 2s1, 2p3. That's not correct because 2s should carry 2 electrons, not 1 electron, before moving to 2p. Now for this one, 1s2, 2s2, 2p6, 3s1, 3p1. This is also not correct because the S shell for 3 should carry 2 electrons, not 1. Then C, 1s2, 2s2, 2p6, 3s0. This tells us that, okay, so there are no electrons in the 3s, and then the 2p orbital is actually filled up. Then let's see D, 1s2, 2s1, 2p1. Okay, so this is also not correct because s orbital should carry 2. So the best answer here would be C. Okay, which of the following electron configurations represent the transition element chromium? So the configuration for chromium 24 is, I think we should write this out and clearly explain it before we look at the answer. Okay, so chromium is 24, right? The configuration for that ideally is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d4. Now ideally this is what it should look like, but then for chromium to be stable, the atomic orbital should either be half filled or completely filled. So instead of having this configuration, it would rather have 4s1, 3d5, such that s orbital, which should carry 2 electrons, carries 1 and is half filled. Okay, then the d orbital, which should carry 10, carries 5 and is half filled. So it's from this point to this point and then to this point. So it's 4s1, 3d5. So the answer is B. Okay, which of the following electron transitions results in emission of energy? Okay, so this is trying to explain how electrons can jump from one energy level to another. So what you should keep in mind is when an electron jumps from a lower energy to a higher energy, it absorbs energy. So it's the absorption of energy that gives it the ability to jump from a lower to a higher energy level. But then if an electron loses energy or emits energy, it goes from a higher energy level to a lower energy level. So loss of energy goes from higher to lower energy level, while absorption of energy goes from lower to higher. So since the question is asking about emission of energy, so it means we're referring to electrons that go from higher energy to lower energy. So 1s to 2s, 1s to 2s is from lower to higher. 3p to 4p is from lower to higher. 2s to 2p is from lower to higher. Why 3p to 3s is from higher to lower? Because 3p has a higher energy than 3s. So the answer is D. Which of the following electronic configuration correctly represents an element in period 3 of the periodic table? So you can figure out the period of an element from the configuration by looking at the highest coefficients we have here. So the highest here we have 2, so it means this element belongs to period 2. The highest here is 4, so it belongs to period 4. The highest here is 3, so this belongs to period 3. Why this belongs to period 2? So the answer is C. So it has 3. This has 3 electron shells. This has 4. This has 2, and this has 2. So the correct answer is C. Which of the following electronic configurations represents that of a noble gas? A noble gas is also called an inert gas, or a rare gas, and it's found in group 8 or group 0. This means that it's a very stable element and it has complete electrons in its outermost shell, so it does not react with any other atom. So looking at the electronic configurations we have here, the one with the stable outermost electron would be A, because the last shell on A has 8 electrons, and 8 electrons shows that it has complete electrons in the outermost shell. So the correct answer is A. Which of the following electronic structure belongs to a noble gas? Okay, so a noble gas has complete electrons in its outermost shell. So looking at this, the third shell has a total number of 5 electrons, 2.5, 2 plus 5, which is not complete because the third shell can carry a maximum of 18 electrons. So this is not complete. Now for this, the second shell has a total number of 2 plus 4 electrons, which is 6. Now the second shell can carry a maximum of 8 electrons, so this is incorrect. Okay, now C, the third shell here has a maximum total number of electrons of 8. 6 plus 2, 8, so this is incomplete. Okay, now these 1s2, 2s2, this is also incomplete because the second shell is carrying only 2 electrons, but it can carry more than 2 electrons. Okay, so I see that the actual answer here is C. So we're looking at the subshells here then. The subshells here, the P shell can carry a maximum of 6, so this is complete. The P is only carrying 3 here, the P is only carrying 4 here, and then the 2s here is incomplete because there is no 2p. So the closest to the answer would be this. Plus, this is number 18, and number 18 is argon. Number 18 is argon, and argon is a noble gas. So the answer is C. But D is beryllium, and which is not a noble gas. That's a metal. So the answer is C. Which of the following elements can conveniently be placed in 2 groups in the periodic table? Okay, so the answer to that question is hydrogen. Hydrogen can be placed in both group 1 and group 7. The reason hydrogen can be placed in group 1 is because it has 1 electron in its shell, and it can lose that 1 electron to form a positive ion when it combines with non-metals. But it can also be placed in group 7 because it is a non-metal. Non-metals are in group 7, and it can also accept 1 electron to complete 2 electrons in the first shell. This happens when it combines with metals. So hydrogen can combine with both metals and non-metals, which means it can be placed in group 1 or group 7. So the answer is A. Which of the following elements has its valence electrons in the s orbital? So let's find out the configurations of these elements and see where the last electrons fall. Then that will tell us what orbital it belongs to. So starting with carbon. Carbon, the atomic number of carbon is 6. The configuration for that is 1s2, 2s2, and 2p2. So 2 plus 2 plus 2 will be 6. So this is a p orbital. The valence electron is in the p orbital. Yeah. Now phosphorus is the 15th element. So 1s2, 2s2, 2p6, 3s2, 3p. Let's see how many is left. This is 10 plus 2, 12. So we have 3 here. Okay. So the valence electron is also in the p orbital. Now for aluminium, with atomic number of 13, 1s2, 2s2, 2p6, 3s2, and 3p1. Okay, so this is 13, which is also in the p orbital. Now for sodium, sodium is 11, so 1s2, 2s2, 2p6, and 3s1. The valence electron here is in the s orbital, so the answer is sodium. Which of the following elements has the electronic configuration of 1s2, 2s2, 2p6, 3s2, and 3p1? Okay, so the configuration here tells us that the total number of electrons here is 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 1, 13. So it means that the atom with this configuration has 13 electrons, or an atomic number of 13. And the one with 13 is aluminium, so the answer is D. Which of the following elements has the highest ionization energy? So looking at these elements, we can tell that, let's see, okay, so going across the period from group 1 to group 7, or to group 8, the ionization energy increases. That means that those in the same period, which are in the same period here, I think it's just fluorine is in period 2. Okay, then chlorine and magnesium are in period 3, while calcium is in period 4. Okay. So if we're looking at the trend as the period is increasing, the higher the period, the lower the ionization energy, which means the ionization energy of calcium is very, very low because it has four atomic orbitals, and so it's easy to knock out the outermost electron of calcium because of reasons like shielding effect and the distance the outermost shell is from the nucleus. So calcium is out of it. Magnesium is also out of it. Now between fluorine and chlorine, although they're in the same group, chlorine is in period 3 while fluorine is in period 2. So it means fluorine will have a higher ionization energy because the shell of fluorine is still closer to the nucleus compared to chlorine. So the answer is B. Which of the following elements is a D block element? So D block elements are transition elements. Okay? And then we could write the electronic configurations of all of this to see where the last electron falls. But then if you study transition metals, you can tell from the options that iron is a transition metal, while all of these are not transition metals. Okay, so when you write the configuration for iron, you find out that the valence electron for iron falls on the D block. So D block elements are also called transition metals, and iron is a transition metal, so the answer is iron. Which of the following elements is a metalloid? So a metalloid is an element that can possess both metals and metallic and non-metallic characteristics. Now if you look at the periodic table, oxygen is a pure non-metal, sodium is a pure metal, and then carbon is a non-metal. So the one that behaves as a metal and non-metal is silicon. Okay, which of the following elements is diatomic? Diatomic means that it is stable when two atoms come together and then form a molecule. Now, the property of diatomicity is mostly found in non-metals. So sodium as a metal can exist as a single atom. Okay? So sodium is often written as Na. You don't find sodium written as Na2 because it's stable as a single monoatomic element. Now, neon is actually very unreactive, so it can exist as a single, although it's a non-metal, but because it's unreactive and stable, it can exist as a single atom. Now, oxygen is a non-metal. Oxygen is not stable as just one atom. So two atoms of oxygen have to come together to give us an oxygen molecule, and that's why you find oxygen written as O2 gas. Now, iron is a metal, so iron can stand on its own as a monoatomic element. So the answer is oxygen here. So which means option C. Which of the following gases is monoatomic? Okay, so metals and noble gases can exist as monoatoms, meaning they can exist and become stable as one atom, while non-metals have to combine to form molecules. So non-metals like oxygen, okay, oxygen is not stable as one atom, so often oxygen molecule is formed from two atoms of oxygen, so you have O2. Chlorine is a non-metal that is also stable when two chlorine atoms come together to give you a chlorine molecule. Nitrogen is also a non-metal that is stable as nitrogen gas N2. Now, argon is a noble gas which is unreactive, so it can stand on its own as a monoatomic element. So the answer is argon. Let's go with argon. Correct answer. Which of the following gases is used to retard the vaporization of filaments in a light bulb? So the answer to this is argon. Argon is the noble gas that is used to retard vaporization of filaments in a light bulb. Which of the following group 1 elements has the highest ionization energy? So in group 1, the one with the highest ionization energy is the one with the least number of shells, because the one with the least number of shells has a valence shell that is closer to the nucleus compared to the others. So the one with the least number of shell is lithium, because lithium has only 2 shells. So the second shell of lithium is very close to the nucleus and it has a strong attraction towards the nucleus. So it takes a lot of energy to knock out the valence electrons of lithium. So the answer is C. Which of the following halogens is liquid at room temperature? So from the properties of halogen, they're usually gaseous. Fluorine and chlorine are gaseous at room temperature, while bromine is liquid at room temperature and iodine is solid at room temperature. So the answer is bromine. Which of the following halogens is solid at room temperature? So the answer is iodine. Bromine is liquid at room temperature, fluorine is gaseous, iodine is solid, and then chlorine is gaseous. Which of the following halogens is the most reactive? So reactivity of halogens decreases as you go down the group. So fluorine, being at the top of the group, is the most reactive halogen. Then the least reactive would be iodine. So the most reactive is fluorine. So the answer is A. Which of the following indicates the correct increasing order of oxidizing power halogens? Oxidizing power refers to the ability of halogens to oxidize other atoms or molecules, and they are able to oxidize other atoms or molecules by how easily they are able to accept electrons that are lost by those molecules that are oxidized. So a halogen with a very strong oxidizing power is one that can easily accept electrons compared to the others. So on the periodic table, fluorine is the most reactive because fluorine easily gains electron compared to chlorine, and chlorine easily gains electron compared to bromine. So as you go down the group, fluorine is the most reactive and iodine is the least reactive, which means fluorine has the strongest oxidizing power while iodine has the least oxidizing power. So if that is arranged in increasing order of oxidizing power, we go from the lowest to the highest. So iodine to bromine to chlorine and then to fluorine. So the answer is D. Which of the following ions has an electronic configuration different from the others? So let's write out the configurations for all of these ions and see which one is different. So starting with the first one, oxygen. Oxygen typically has 8 electrons. Okay, so 1s2, 2s2, 2p6. Oh, 2 plus 2 is 4. Okay, so plus 4. Okay. Or we could use the 2-8 configuration because we're dealing with the first 20 elements. So with the first 20 elements, the 2-8-8 configuration is actually much easier to use. We could also use this. So let's use this. And we'll also use the 2-8-8 and see. So with this, we have 1s2, 2s2, and 2p4. When oxygen loses 2 electrons, it gains 2 electrons, sorry. Minus 2 means oxygen gains 2 electrons. So if oxygen gains 2 electrons, that means 4 goes from 4 to 6. So it means as an ion, it will form 1s2, 2s2, and 2p6. Now for aluminium is 13. So 1s2, 2s2, 2p6, then 3s2 and 3p1. Now for aluminum to form an ion, it loses 3 electrons. So this electron and this electron goes. So we're left with only 1s2, 2s2, and 2p6. Okay, so chlorine is 17. So 1s2, 2s2, 2p6, 3s2, 3p6. 17, right? So 6 plus 2 plus 2, 10. Okay, so this should be 5. 3p5. Now chlorine forms a negative ion by gaining 1 electron. That's why it's minus. So when it gains 1 electron, 3p5 becomes 3p6. So we have 1s2, 2s2, 2p6, 3s2, and 3p6. Now lastly, magnesium. Magnesium is 12. So 1s2, 2s2, 2p6, 3s2. So this is 12. 6 plus 2 plus 2 plus 2 is 12. Now for magnesium to form a positive ion, it loses 2 electrons. So it will lose the 2 electrons we have here. So we're left with 1s2, 2s2, and 2p6. So this, and this are the same. So the odd one is chlorine, which means the answer is C. Now, which of the following ions has the electronic configuration 288? Okay, so 288, this time around we get to use the 288 configuration. So let's write out the configurations of the ions. Now magnesium has an atomic number of 12, which usually is 282. But then when magnesium forms an ion, 2+ ion, it loses this last 2 electrons we have here, and then it forms 288. Oh, just 28, sorry. It forms just 28 because the 2 here is gone. Now sodium with an atomic number of 11 forms 281. Now when it forms an ion, it loses 1 electron. Okay, it loses 1 electron to form 2,8 because this 1 electron goes. Now for fluorine is number 9, so 2,7. Now for fluorine to form an ion, it gains 1 electron. When it gains 1 electron, this increases to 8, so we have 2,8. Now for chlorine is 17, so usually it's 287. But when it forms an ion, it gains 1 electron, and then this goes from 7 to 8, so you have 288. The final answer is chlorine, D. Okay, which of the following ions has the same electronic structure as argon? All right, so we need to write out the ions for all of these and see if it's the same as argon. So first of all, let's write out the configuration for argon. Then we can use that as a standard to check the other ones. Now argon has an atomic number of 18. Okay, so using the 288 configuration, that's 2, Okay, let's see. We might want to use the 1s2 configuration, but I think the 288 can work here. So 28, the only exception will be for bromine. So 288 gives us a total of 18. Yeah. So now when let's see. So nitride ion, nitrogen has atomic number of 7. So nitrogen would normally be 2,5. So 5 plus 2 is 7. Now it gains 3 electrons. So this could complete 8. Okay? So when it gains 3 electrons, it becomes 2,8, which is not the same as this. Now for phosphide from phosphorus, phosphorus has an atomic number of 15. Okay, so 15 is 2,8,5. Now when phosphorus forms an ion, it gains 3 electrons, 3 plus, 3 minus, sorry. So the configuration becomes 288. I think we found our answer. For oxygen, oxygen is number 8, so that's 2,6. So when oxygen forms an ion, it gains 2 electrons and becomes 2,8. So bromine may not follow the 288 configuration. It's more accurate to use the 1s2 2s2 configuration, but we already have our answer here, phosphorus. So phosphorus is the one that has the same configuration as argon. So the answer is C. Phosphide ion. Okay. Which of the following ions is isoelectronic with neon? So isoelectronicity refers to 2 ions or atoms or molecules that have the same number of electrons or the same electronic configuration. Okay, so if we check all of these ions, let's see which ones have the same electronic configuration. Now for fluorine is usually 2,7, but when it gains 1 electron, it becomes 2,8. Chlorine number 17 is usually 287. When it gains 1 electron, it becomes 288. Now for potassium, which is number 19, okay, 19 is usually 2881, but it loses that 1 at the end to become just 288. Okay, then lithium number 3 forms 2,1, but then it loses the 1 at the end to just be 2. Now, so which of this is the same as neon? So let's write for neon. Neon has an atomic number of 10, which is 2 and 8. So 2 plus 8 gives us 10. So the one that is isoelectronic with neon is fluorine, because they have the same electronic configuration, which means they have the same number of electrons. So the answer is A. Which of the following is correct about electrons in the 1s orbital? They have the same spin. Now this is incorrect because 1s orbital carries 2 electrons, okay, and 2 electrons spin in opposite direction. So it looks like this. If this is the s orbital, you have 2 electrons in, so one is spinning in the clockwise, the other is in the anti-clockwise direction. So A is incorrect. Are easier to remove than those in the 2p orbital. This is also correct because the 1s orbital is closer to the nucleus than the 2s orbital. Actually, the 2p orbital. So this is 1s, this is 2s, and just assume this is 2p, okay? So the one closer to the nucleus has a stronger attraction to the nucleus, so it's not easily, electrons are not easily removed from those orbitals. So 1s is closer to the nucleus than 2p, so it's not easy to remove electrons from 1s. now are closest to the nucleus. That is true because 1s orbital is the first orbital after the nucleus, so it's very close to the nucleus. Now D have the same energy as those in 2s. This is incorrect because 2s orbitals have higher energy level than 1s orbital. So 1s orbitals have low energy level. So the answer is D. Okay, so we go with D. Which of the following is not a halogen? Okay, so halogens are group 7 elements, and then they are fluorine, bromine, chlorine, iodine, and astatine. So the odd one is silicon. Silicon is a group 4 element. Which of the following is the configuration of sodium ion if the atom is represented as this? Okay, so sodium ion is formed when sodium loses one electron. Okay, so the actual configuration for sodium atom is 1s2, 2s2, 2p6, and 3s1. Now, but when it loses this one electron and becomes an ion, plus 1 showing us that it lost one electron, it becomes 1s2, 2s2, and 2p6. So this is the configuration for sodium ion, and that is option C. The correct answer is C. Which of the following is or are true of elements in the periodic table? Okay, so all elements in the same period have atoms with the same number of main electronic shells. This is correct. So period just refers to the number of main orbitals or main electronic shell of an atom. So elements in period 3 have 3 electronic shells. In period 4 have 4 electronic shells. So 1 is correct. 2. The atoms of the elements are arranged in order of increasing number of electrons. This is also correct because increasing number of electrons refers to also increasing atomic number. Okay, and then the elements are arranged according to their increasing atomic number. Now the last member of each period is a noble gas. This is also correct because the last period is period 8 or period 0, and they're usually noble gases because they are unreactive and they have complete electrons in their outermost shell. 4. All the elements in the same group have the same number of electrons in their outermost shell. This is true because the group is defined by the number of electrons they have in their outermost shell, or the valence electrons. So 1, 2, 3, and 4 are correct. Which of the following noble gases has electronic structure similar to that of nitrogen in ammonia? Okay, so let's find out what the electronic structure of nitrogen is in ammonia by first finding what the combining power of nitrogen is in ammonia. So in ammonia, NH3, okay, so here nitrogen is has a combining power of 3, hydrogen has a combining power of 1. So the subscript we have here are exchanged usually. So it means nitrogen has a combining power of 3, hydrogen has a combining power of 1. So what happens here is nitrogen has to gain 3 electrons and hydrogen has to lose 1 electron, okay, for this bond to be formed, right? So it means that for nitrogen to have lost 3 electrons, the original configuration for nitrogen as the 7th element is 2, 5, okay? But when it gains 3 electrons, not loses, it gains 3 electrons, it becomes 2, 8, while hydrogen loses 1 electron. So which of these has an electronic structure that is similar to 2, 8? So the answer there is neon, because neon is number 10, so 2 plus 8 would give you 10. It is not helium because helium has only 2 electrons. It is not argon because argon has 18 and krypton has 36. So the one that would give us a total of 10 electrons is neon. So the final answer is B. Okay. Which of the following non-metals react most readily with metals? So the question is, which nonmetal is the most reactive? So the answer is chlorine, because halogens on the other end of the periodic table are more reactive than these other nonmetals. Okay, so chlorine combines easily with metals than sulfur, nitrogen, and carbon. Which of the following pairs of elements has the greatest difference in electronegativity? So difference in electronegativity, you can deduce that from the distance between the groups. So sodium is in group 1, okay, and all of these are in group 7. So we can then use the change in the periods of the halogens. Now, the electronegativity of the halogens would decrease down the group. Yes, it decreases down the group. So fluorine has the highest electronegativity, and then the lowest electronegativity is iodine. So which means the difference in electronegativity between sodium and the halogens will be between sodium and fluorine, since fluorine has a higher electronegativity than the other ones. The answer is A. Which of the following pairs of letters denotes elements containing the same number of electrons in their outermost shell? Okay, there should have been a table for this, but there is none, so this question will be flagged. The letters here should have been denoted in a table, so we'll skip this question. But then remember that elements in the same element that have the same number of electrons in the outermost shell are elements that belong to the same group. Now the next question, which of the following pairs of letters denotes elements containing the same number of electrons in their outermost shell? Okay, now we have a table for this one. So these are the groups, group 1 to group 8. So those in the same group have the same number of electrons in the outermost shell. So A and E belong to the same group. Then B and G belong to the same group. So that means the answer is B and G, because we don't have A and E in the option. The next one would be B and G. So B and G belong to group 8 of the periodic table. Which of the following pairs of properties of alkaline metals decreases down the group? Alkaline metals are group 1 metals or group 1 elements. So going down the group, let's see which pair of properties would decrease down the group. So the melting point and the atomic radius, all right? So the atomic radius actually increases down the group, and the melting points of metals also decreases down the group, because the metallic strength of the bond decreases down the group as the attraction between the electrons and the nucleus decreases. So both melting point and atomic radius decreases down the group. So the answer should be A. Let's check out and make sure that the other ones. Now the first ionization energy refers to the energy that is used to remove the outermost electron of a neutral atom to form a +1 ion. So as you're going down the group, the number of shells increases and then the ionization energy decreases. Okay, so going down the group, the first ionization energy decreases. Oh, the atomic radius increases. Did I say it decreases? It increases because as you're going down the group, the number of electron shells increases, and then the distance from the outermost shell to the nucleus also increases. So the atomic radius increases. So it's not A. So the first ionization energy decreases as you're going down the group, and so does the melting point. Now the reactivity of group 1 elements increases as you're going down the group, because as you go down the group, it becomes easier for them to lose electron, and their reactivity is defined by the ease with which they lose electron. Now the electronegativity increases across the period and decreases down the group. So reactivity increases but electronegativity decreases, so it's not this pair. Now for the last one, first ionization energy decreases down the group, but the reactivity increases. So the correct answer is B. Which of the following processes is not exhibited by atoms in order to attain more stable electron configuration? So another way to ask the question would be, why do atoms, or what do atoms do in order to gain stability? Now, they gain electrons, they lose electrons, and they also share electrons to gain stability. And that's why we have ionic bonds and covalent bonds that describe what happens here. But hybridization does not apply to gaining stability, so the answer is D. Which of the following properties is characteristic of halogens? So halogens are group 7 elements, okay? And then group 7 elements have 7 electrons in their outermost shell, so they accept 1 electron to become stable. So which of the properties is characteristic of halogen? Ability to accept electrons easily, which is true because they can easily gain 1 electron to become stable. Now, they don't donate electrons, okay? They don't form colored compounds, that's transition metals, and they form acidic oxide, not basic oxides. So the answer is the ability to accept electrons easily. Which of the following properties of atoms generally decreases down a group in the periodic table? So as you're going down the group, let's see, electronegativity increases across the period and decreases down the group. So that's not the answer. Ionization energy increases across the period and decreases down the group. Ionic radius decreases across the period and increases down the group. Electron affinity increases across the period and decreases down the group. So the answer is ionic radius. Which of the following properties of element decreases generally across a period in the periodic table? Okay, so electron affinity increases across the period but decreases down the group. Electronegativity increases across the period and decreases down the group. Atomic radius decreases across the period but increases down the group. Atomic radii is just a plural for atomic radius. So atomic radius would best describe the radius of an atom. So we'll go with atomic radius, not atomic radii. Which of the following properties would not influence electrovalent bond formation? So electrovalent bond formation is formed when a metal and a non-metal combine to form stability by losing and gaining electron. So the metal loses electron and the non-metal gains the electron, and then they both form ionic compounds. So which of these would not influence the formation of ionic bond? Catalytic ability, that's the answer, because electronegativity affects the formation of electrovalent bond, because if the electronegativity between the two atoms is very large, then they will form electrovalent bond. But if it is very small, then they will form covalent bond. Now, electron affinity has to do with the energy that is released when an atom gains electron, and gaining of electron happens when electrovalent bond is formed. So electron affinity also affects that. Ionization potential refers to the potential of an atom to ionize by either losing or gaining electron. So that also influences. So the answer is catalytic property or catalytic ability. Which of the following reactions is accompanied by the first ionization energy of an element X? Okay, so element X belongs to group 4 of the periodic table. So the first ionization energy is the energy that is required to remove the electron from the outermost shell of an atom to form a +1 ion. Okay, so which means first ionization energy only removes 1 electron from the outermost shell. So although X has 4 electrons in the outermost shell, the first ionization energy will only remove 1 of the electrons to give you X +1. So which means which of these correspond to that? It would mean that the let's see, the neutral atom X loses an electron to form X plus. So B cannot be the answer, because if X is neutral and it loses an electron, the X in the product is also neutral. So the best answer is D, because X on the left hand side is neutral. Then when it loses electron here, it becomes X plus. So the answer is D. Which of the following set of elements are arranged in order of decreasing atomic size in the periodic table? Okay. All of these elements we can see belong to the same period, so they differ in their groups. So what we pay attention to is the trend of the atomic size as you're going across the period, where the groups are increasing. Now, across the period, atomic size would decrease, because as you're going across the period, the effective nuclear charge increases. The nuclear charge refers to the number of protons in the nucleus, which is also the atomic number. So as you're going across the period, atomic number increases, which then increases nuclear charge. When nuclear charge increases, there's a stronger attraction between the nucleus and the outermost electron. So which means if there is a stronger attraction between the nucleus and the outermost electron, you need more energy to be able to remove an electron from the outermost shell. So as you go across the period, the atomic size, we're referring to atomic size, not ionic energy, ionization energy, sorry. The atomic size would decrease, because as the nucleus pulls in the outermost electron, it decreases the size of the atom, because the electron shell starts to go closer to the nucleus due to the pull between the nucleus and the outermost shell. So the size of the atom decreases across the period. So if we are to arrange this in order of decreasing atomic size, we go from the highest to the lowest. So the highest atomic size would be from the lowest group. So the lowest group would be beryllium, followed by carbon, then nitrogen and oxygen. So oxygen has the lowest atomic size, but beryllium has the highest atomic size. So the answer is C. Which of the following set of elements is arranged in order of increasing first ionization energy? So the first ionization energy refers to the energy required to remove one electron from the outermost shell of an atom to form a +1 ion. Okay. Now, as you're going, let's see, the elements we have here are all in group 1. So since they are in the same group, the periods are different. So as you're going down the group where the periods differ, the trend of ionization energy decreases, because as you keep increasing the number of shells as the period increases, the distance from the outermost shell to the nucleus is larger, and since it is larger, the force of attraction between the nucleus and the outermost shell decreases, and so it becomes easy to knock off the electrons from the outermost shell. So the ionization energy decreases as you're going down the group. So which means the one with the strongest ionization energy will be lithium, while the one with the lowest ionization energy will be rubidium. So the answer is B. So, not B, sorry. Lithium, potassium, sodium, and rubidium. It should be lithium, sodium, in order of increasing first ionization energy. Increasing refers to the lowest to the highest. Oh yeah. So lowest to the highest mean that rubidium has the lowest, followed by potassium, then sodium and lithium. So the correct answer is D. So lithium has the highest first ionization energy, while rubidium has the lowest. Okay, which of the following species has the largest ionic radius? Now, with ionic radius, we compare the radius of the ion to that of the actual neutral atom, and we learned that the ionic radius of a cation is usually smaller than that of the neutral atom, because as the cation loses electron, the shell becomes empty and then it disappears, and then we're left with lesser number of electron shell. So what that looks like is this. Okay, let's give an example of one cation and one anion. So if I pick potassium here. Potassium is 19 and it's usually 2881. Now when potassium forms an ion, it's going to lose this one electron, so the shell becomes 2, 8 and 8. Okay, so there are only 3 shells here, but the neutral atom has 4 shells. So this one, the radius of this is larger than the radius of this. So for cations, the radius of the ion is usually smaller than the radius of the actual neutral atom. But with an anion, like let's see, chlorine is 17, so 287. When chlorine forms an ion, it becomes 288 by gaining 1 electron. Now the reason why the ionic radius for this is larger than this is because the more the electron increases, the more repulsion you have between the electrons, because electrons are all negatively charged and like charges repel each other. So 7 electrons and 8 electrons, 8 electrons will have more repulsion than the 7 electrons, and as the electrons repel each other, they increase the size of the atomic orbital. So the chlorine ion is larger than the chlorine atom. Okay, so it means that the answer is between sulfur and chlorine. Now for sulfur, it gains 2 electrons, while for chlorine it gains 1 electron. Now sulfur is in atomic number of sulfur is 16. That's 2,8,6. Okay, so when it gains electrons, it becomes 2,8,8. Now this one gained 2 electrons, so gaining 2 extra electrons would further repel the rest of these electrons. Now for chlorine, it gained only the 1 electron. Now although the configurations are the same thing, but because sulfur gained 2 electrons, it will have much more repulsion than the actual neutral atom. So the size of sulfur ion would be greater than the actual neutral atom of sulfur. So the answer would be B. Okay. Or something else I'm thinking about, the ionic radius, the trend of the ionic radius down the group and across the period. Okay, so ionic radius follows the trend of atomic radius, and it decreases across and increases down. So sulfur and chlorine are in the same period, but they're in different groups. So in different groups across the period, ionic radius decreases, which means chlorine would have a larger ionic radius than sulfur. Okay, that's a better explanation for that. So across the period, because the emphasis is on periodic trend, so the emphasis is that as you're going across the period where the groups are increasing, the ionic radius is also is decreasing. So as it's decreasing, sulfur is in group 6 while chlorine is in group 7. So as you're going across this way, the ionic radius is decreasing. So what this means is that this has a larger ionic radius than this. Oh, we were right the first time. Okay, we were right the first time, but then the explanation is, we use the explanation for the trend of the ionic radius. Okay, so it means that the one with in group 6 has a larger ionic radius than the one in group 7, which means sulfur actually has a larger ionic radius than chlorine. So the answer is B. So we'll go with B. All right. Which of the following statements is or are correct about the trend of ionization energies of elements in the periodic table? Okay. So the noble gases have higher ionization in each period. This is true because I think this should be the noble gases have the highest ionization energy. This is true because the noble gases are stable, and so they have a very good grip on the electrons they have in the outermost shell, so they don't lose those electrons. So they have a very, very high ionization energy. It takes a lots of energy to be able to knock out the electron of a noble gas. Then ionization energy decreases down group 1 element. As you're going down the group, the number of electron shell increases, the distance from the nucleus to the outermost electron also increases, so the attraction decreases, and so you need less energy to knock out electrons as the shells increases. So 2 is correct also. Now, ionization energy generally increases from left to right of the periodic table. This is also true because as you're going from left to right, the atomic number increases, so does the nuclear charge increases, and as the nuclear charge increases, there's a stronger attraction between the nucleus and the outermost shell, the electrons in the outermost shell, and so it takes more energy to remove those electrons in the outermost shell. So 3 is also correct. Now, the alkali metals have the lowest ionization energies in each period. Okay, the alkali metals are those in group 1, and they do generally have the lowest ionization energy because as you move across the period, the ionization energy increases, so group 1 will have the lowest ionization energy. So the correct answer should be 1, 2, 3, and 4. Okay, so we don't have that option here, but 1, 2, and 3 comes close to the answer, so we go with 1, 2, and 3. But ideally 1 to 4 are all correct. So which of the following statements about elements in group 7 is correct? So elements in group 7 are the halogens. So let's see. Generally, halogens are very good oxidizing agents because they accept the electrons that are lost by those species that are oxidized, so they themselves become reduced. So they are very good oxidizing agents. Now, but comparing the halogens, the oxidizing ability of halogens as you go down the group, okay, so fluorine has the strongest oxidizing ability. So as you go down, the oxidizing ability decreases. So bromine will oxidize chlorine. That's not true because chlorine has a stronger oxidizing ability than bromine. So chlorine will actually oxidize bromine, not this way. So iodine is a stronger oxidizing agent than fluorine. This is also not true because fluorine is the most reactive, so it would oxidize iodine instead. Chlorine will oxidize iodine. Now this is true because chlorine is higher on the group than iodine, so chlorine is more reactive than iodine and would oxidize iodine. F2 has the least tendency to be reduced. This is not true because fluorine is very reactive and can easily get reduced by gaining electron. So the correct answer is C. Which of the following statements about group 7 elements is correct? Okay, so group 7 elements are the halogens: fluorine, chlorine, bromine, iodine. So they exist as monatomic molecules. Monatomic molecules meaning that they can stand on their own as single molecules without having to form diatomic molecules. But halogens actually exist as diatomic molecules in this way, which means you have 2 atoms of each of them coming together to form a diatomic molecule to make it stable. So they don't exist as monatomic molecules, they exist as diatomic molecules. Now they are present in the same physical state. This is not true because bromine is liquid at room temperature, chlorine is a gas at room temperature, fluorine is also a gas at room temperature, but iodine is a solid at room temperature. So they do not have the same physical states. Now they are strong reducing agents, which is true. They are actually strong reducing agents because they are strong oxidizing agents because they themselves become reduced by accepting electron. So they are strong oxidizing agent, not strong reducing agent. Now their reactivity decreases down the group. This is true because fluorine is the most reactive and iodine is very, very less reactive. So as you're going down the group, the reactivity of the halogens decreases. So the correct answer is C. So they are oxidizing agents, not reducing agents. Let's go with C. Which of the following statements about ionic radius is correct? So ionic radius decreases as nuclear charge decreases, increases as nuclear charge increases, decreases as nuclear charge. Okay, so we're trying to see the relationship between ionic radius and nuclear charge. So ionic radius is similar in trend to atomic radius. So as nuclear charge increases, the attraction between the nucleus and the outermost shell increases, and so the outermost shell is pulled closer to the nucleus, and that pull tends to decrease the size of that atom or that ion. So if the nuclear charge increases, the ionic radius will decrease. So let's see, ionic radius decreases as nuclear charge decreases is wrong. It increases as nuclear charge increases, that's wrong. It decreases as nuclear charge increases, this is correct. It doesn't remain constant because it's affected by nuclear charge, so the answer is C. Okay. Which of the following statements about rare gases is correct? Okay, so rare gases have a lone pair of electron. A lone pair of electron. Okay, let's see the other ones. They are generally reactive. That's not true because they are unreactive, because they have completely filled electrons in the outermost shell, so they are not reactive. The outermost shell are partially filled, that is wrong. The outermost shell are actually completely filled. Now the outermost shell are fully filled, so this is correct. So that means A is wrong. They don't have a lone pair of electron. They actually have 4 lone pairs of electron that makes 8 electrons. So the correct answer would be D. They have the outermost shell are fully filled. Which of the following statements about the behavior of an atom is correct? Okay, so let's see. This is a relationship between anions and their parent atom. So anions, once they form, they accept electrons to form negative ions. And as they accept electrons, the atomic size or the ionic size of that ion increases because of the repulsion between the electrons. Electrons are negatively charged, so they are like charges, and so they repel each other. So the larger the repulsion, the more the increase in size of the ion. So anions are generally larger than their atom, not smaller. They are larger because the size increases as the repulsion of electron happens. So A is wrong. Atomic size increases across the period. This is also wrong because as you go across the period, nuclear charge increases. And as nuclear charge increases, there's a stronger pull between the nucleus and the outermost shell. So the pull between the nucleus and the outermost shell decreases the size of the atom. Now, C, cations are smaller than their parent atoms. This is true because when cations are formed, they lose electrons in the outermost shell. And as they lose electrons, the number of shells they have reduces, which in turn reduces the distance between from the nucleus to the outermost shell. So cations are usually smaller than the parent atom, so this is correct. Now atomic size decreases down the group. This is wrong because when you go down the group, atomic size increases. So C is the answer. Which of the following statements is correct about ionization energy? Okay, so it causes metallic nuclei to integrate, to disintegrate. Okay, so ionization energy is the energy required to remove electrons from the outermost shell of an atom to form a positive ion. Okay, so let's see the options. We'll come back to A. It decreases across the period. Ionization energy actually increases across the period because the nuclear charge and the force of attraction between the nucleus and the outermost electron makes it more difficult to remove electrons from the outermost shell. So it actually increases across the period. It results in the formation of an anion. This is not true because when electrons are lost from the neutral atom, they form a positive ion called cations. It decreases down the group. Yes, this is correct. So ionization energy decreases down the group because as you go down the group, the number of electron shells increases. And so as the number of electron shells increases, the distance between the nucleus and the outermost shell increases. And that increase in the distance results in a reduced attraction between the nucleus and the outermost shell, and because of that, it is easy to knock out the electron in the outermost shell the farther away it is from the nucleus. So as you go down, the ionization energy increases, which means it actually does not cause metallic nuclei to disintegrate. Okay, which of the following statements is not correct? Group 7 elements, okay, are good oxidizing agent. This is true because oxidizing agents get reduced by accepting electron, and group 7 elements can accept one electron to become stable, so they are good oxidizing agents. They are diatomic. Diatomic is also correct because they exist as diatomic molecules in this form. For instance, fluorine does not exist as a single atom, it exists as two atoms of fluorine forming a molecule. So also does chlorine and iodine and bromine. Okay, so they do exist as diatomic molecules. Now they have relatively low ionization potentials. That's not true because they can easily become ionized by gaining one electron. And because they only need one electron, it becomes easy for them to gain that one electron. So they have very high ionization potentials. That's the potential to form an ion. Now they have high electronegative, or they are highly electronegative. This is true because electronegativity describes the ability of an atom to accept electron. So group 7 elements can easily accept one electron, so their electronegativity is very high. The correct answer is D. Okay, which of the following statement is not correct? The 4s orbital contains a maximum number of 2 electrons. This is true because the s orbital can take a maximum number of 2 electrons. It's defined by the quantum number L equals 0. So L refers to the subsidiary quantum number. The subsidiary quantum number refers to the subatomic orbital. Now, the number designated for the subatomic orbitals are S would be 0, P is 1, D is 2, and F is 3. So since the subatomic orbital here is S, it means that the L would be 0 because S is denoted by 0. So this is correct. Now, it's spherical about the nucleus. So the shape of the s orbital is spherical. So this is also correct. It's of higher energy than 3d orbital. Now this is wrong because the 4s orbital has a lower energy than the 3d orbital. So the answer is D. Which of the following statement is not true of halogens? They exist in different physical states. That is true because chlorine and fluorine are gases, bromine is a liquid, and then iodine is a solid at room temperature. So they do exist in different physical states. Now their melting and boiling points increase down the group. Okay, so the melting and boiling points of halogens, let's see. Okay, we'll come back to this one. Let's look at option C. They exist as diatomic molecules. This is true because halogens are not stable as monoatomic gases. So we see them represented as F2, Bl2, Br2, I2. This means that they need 2 atoms of fluorine for this to be stable, 2 atoms of chlorine. So because 2 atoms of each of these halogens combine to become stable, that's why they are called diatomic molecules. Now the ionic radii decreases down the group. So generally, ionic radii decreases across the period and increases down the group. So it increases down the group, not decreases down the group. So it means that D is correct. Now their melting and boiling point increases down the group is also correct. Yes, the trend of melting and boiling point is that the melting and boiling point increases down the group, yeah, and decreases across the period. Okay, so that means the answer here is D. Let's go with option. All right, Which of the following statement is true? Cations are smaller than the parent atom. Now this is true because when cations form, when a neutral atom loses an electron, the number of shell it has reduces, and that in turn reduces the radius of that ion. So cations, because they lose electrons, they're usually smaller than the original atom. That's true. Now atomic size increases across the period. That is wrong because it decreases across the period. Then it increases down the group, not decreases down the group. Now anions are generally larger than the parent atom, not smaller, because when they accept electron, the repulsion between the electron increases the size of the ion. The correct answer is A. So which of the letters indicates elements that exist as diatomic gases? Looking at the question, there are not enough information to answer this question. So this question has been flagged. Let's move to the next question. Which of the letters indicates elements that exist as diatomic gases? Okay, so diatomic gases are usually non-metals. Non-metals are those that exist as diatomic gases. Now, an exception to that rule will be noble gases. Noble gases are stable, although they are gases, but they are stable, so they do not combine with any other element. Now, the non-metal I see here is letter F. Now, but if you look at A would represent hydrogen here in group 1 and period 1. So hydrogen is actually a non-metal, but it is placed in group 1 because it usually loses one electron when it combines with non-metals. So, but it does exist as a diatomic gas, H2, then F. So the answer is A and F. So we go with A and F. Which of the letters represents an alkaline earth metal? Alkaline earth metals are found in group 2 of the periodic table. So the letter found in group 2 is C. The correct answer would be C. Which of the letter represents an alkaline earth metal? Okay, so this question also does not have enough information for us to give an answer. So we're going to skip this one too. Which of the orbitals 4s, 4p, 4d, and 4f has the lowest energy? Okay. The lowest energy, according to the order of arrangement of energy orbitals, is 4s. 4s has the lowest energy. 4f has the highest energy. Which of the orbitals has the lowest energy? Okay. The lowest energy is 4s, while the highest here will be 4f. So 4s is lower than the rest of the energy levels we have here. Okay, so this brings us to the end of the WAEC questions for periodic table and properties.